Hello, good morning, dear participants. I welcome you all on the fourth day of STC, Industry 4.0 and Smart Manufacturing Opportunity and Challenges. So, in today's first session, Professor Lakshman Pandey sir from IIT Delhi will be delivering a talk on the computation methods in Industry 4.0. So, sir has already joined us. So now I welcome and invite sir to deliver his talk. Hello sir, are you there?
Hello.
Sir, are you there, sir?
Yeah. Can you hear me?
Yes, sir. Yes, sir. I can hear you, sir.
Okay.
Okay. Okay, sir. Please start, sir.
Yeah. So, good morning, all of you. Arun is there.
Hello, good morning, sir. Hello,
Arun is there. Okay. So, today let me talk about that. Today's session is planned for use of computational methods for Industry 4.0. Like if you remember my last lecture, previous lecture, which I have delivered day before yesterday, I talked about the various building blocks of Industry 4.0. So this various building blocks of Industry 4.0 are something which I want to share once again for you. Okay, so my screen has come.
Yes, sir.
You can see now the building blocks of Industry 4.0. This is what I have discussed in the last class for all of you. Is it okay? So you can see the cyber physical system. Cyber physical system, as indicated by me on that day, which is actually shown like this, correct? Requires a lot of information at its core, and which is being dealt with, which is this information is to be used using various computational tools to really dig out a proper information or a suitable information required for any action, any job to be made, or any work, any component to be fabricated. Then communication has to be done, and obviously the communication is very important point, because the structure of the machines are something like this. This is what I discussed on that day, correct? This is how the structure of the machines are. So they are supposed to communicate with each other, and then it comes to the controls. So obviously these things are going to control the cyber, the various machines. So the cyber physical system is actually the heart of the Industry 4.0. And in this cyber physical system, whether you really want to dig out the information, optimum information, you need to apply some machine learning or artificial intelligence techniques. You have to do the communication, you have to control the system. So computation is something which you cannot avoid, because that is again, I'll say, a very important aspect of cyber physical system. It is a kind of artery, one of the arteries of the cyber physical system, if you call the cyber physical system as a heart of the Industry 4.0, correct? So the various building blocks which I talked about, Industry 4.0, were you can see here that so many things are there, at least 6 to 8 things are there, in which one important point is the big data, correct? Big data and digging out the relevant information from that big data, and then trying to optimize that information. So my today's topic, I have discussed about additive manufacturing in my previous class. So today my idea is to talk about certain computational methods, not too many, but definitely I would like to focus on two things. One is the optimization techniques, and other would be the design of experiments, correct? So I am talking to you for maybe 30 to 40 minutes, and after 45 minutes there's a PhD student of mine, Mr. Arun Kumar, correct? He will be showing you the things, how the things are done. So he will show you the various design of experimental methods. He will demonstrate you, because design of experimental methods are also one of the artificial intelligence technique. They are considered to be one of AI techniques, though the machine learning is the most advanced one, where I will say the deep learning part, which is based on I believe one of the tools may be the artificial neural network, which is a component of deep learning, is one of the most advanced thing. But I'm not going to talk about that, but I'm going to talk about certain primitive things which actually formulates the backbone of all these things. They are the optimization algorithms and design experiments. They are also are the tools if the data is not highly complicated, correct? So let me move to the another slide, another presentation now. Let me come to this. Okay, so I believe you can see the another slide now. Gradient based optimization method. Is it okay? So gradient based optimization method, which is also a indirect search method. Now there are variety of optimization problems. What is exactly optimization? Can anybody tell me what is exactly optimization is? Yeah, what is optimization is? Can anybody tell me? Hello. So what is optimization? Like in many engineering problems, what do you see? You see that there is an objective function, and there are many constraints, correct? If you want to solve any engineering optimization problem, or maybe any other kind of optimization problem, may not be engineering, maybe societal, maybe medical, maybe some financial or economical optimization problem. First thing, the word optimization means maximization or minimization, correct? So there will be one objective that you want to either minimize or maximize, and sometimes there is also one kind of optimization problem where you want to achieve a particular number, that is a particular nominal value that you want to achieve. So that may be classified as third kind of optimization problem, that I want to get this particular target. I don't want to optimize, I don't want to minimize. But in general, the optimization is defined as a maximization or minimization of a objective function. And once there's a this maximization or minimization of objective function, you will find that there are certain ways to define it. Let me just come to it. Now the problem of optimization may be of different kinds, correct? The optimization problem may be having some sort of, I'll say, this is how a general optimization problem is defined, correct? So you want to minimize a function. There may be one, if there's only one function at a time, it is a single objective optimization problem. If there are more than one function at a time, then it is a multi-objective optimization problem, correct? Now, the objective functions may be unimodal type. Unimodal type means you have a only one peak, like you see that there is parabola. So parabola is either have a top or a bottom. There is one peak only. You cannot have a situation like you have a fourth order equation kind of thing, the oscillating kind of curve, where there are so many minimas or maximas, correct? So a general constraint minimization problem can be stated as minimize fx or maybe f1x, f2x, f3x if it is a multi-optimization problem subjected to number of constraints. So the constraints may be of two kinds. One kind of constraint is called inequality kind of constraint, which is generally represented as gix is less than or equal to 0. And there may be so many, like 1 to m, there are m such constraints. So this is an inequality type constraint. And there may be an equality type constraint. Equality type constraint may be hjx is equal to 0. So hjx is equal to 0 and the j goes from 1 to up to p. So there are another number of such optimization, constraints are there. So within considering these constraints or under these constraints, you have to minimize or maximize this function. This kind of a problem is called an optimization problem. Correct? Like in engineering, the optimization may be like suppose I'll give you another one example. Suppose you want to design a beam, and you are designing a beam for a very typical application. The load is non-uniform, and the load is very high at certain places, and it is very low at certain other places. So in order to reduce the weight of the beam and in order to reduce the material of the beam, you won't like to have a uniform cross section everywhere on the beam, correct? Now suppose you are doing the same thing, you are trying to design the same thing in the environment of industry 4.0. So what you will do, you will simply input your problem in digital form to one of the programs, I'll say, or one of the softwares, and that software will send that digital data to the cloud. In that cloud, there's a lot of information about such kind of problems. So automatically, the software should be able to dig out a relevant information that what kind of beams are available which can be useful for such a problem. So there will be a very typical software will try to decide a kind of beam. Then that kind of beam structure will be optimized using some kind of optimization algorithm. So for selection, you may need a algorithm which may be simple algorithm which may require some artificial intelligence. And for minimization of the structure, weight, or its topological optimization, you need to have another optimization algorithm which will run and which will give you the exact solution that will be the exact designed beam for your particular application, correct? So this is an example of a simple I'll say optimization problem, a general optimization problem which I have for a single objective which I have to show through these three statements here, correct? Now let me come back. Now suppose if this kind of problem is there. Now here x, you please note that this x is a design variable or a decision variable. This x is a design variable or a decision variable. It may be, it is not single, it is not fx. This x is actually x1, x2, x3, x4, x5. There may be so many, decision variables or design variables. Like for example, you are doing turning process, for example, and in turning, the surface quality of the turn job is dependent on, say for example, number of parameters. It depends on the initial surface quality, it depends on the speed, feed and depth of cut of the which you select during turning operation. It depends on the capability of the machine tool also, because the vibrations of the machine tool, they are important because they they govern the surface quality or the waviness which comes onto the surface of the job. So many factors. So this X is actually X1, X2, X3, X4, X5 kind of thing, which is a decision, a variable or a design variable. This is what you are going to find out, which will actually minimize FX or maximize FX, correct? So I believe I made it clear that what is the optimization problem. Now, there are number of algorithms to solve this problem, correct? I believe some of you might have already studied in your BTech curriculum or sometimes in your PG curriculum, because you can always do a long course of 40 to 42 hours in conventional optimization, and also you can do a full course on evolutionary algorithm, correct? So what I would like to tell you that this is one of the example which one of the optimization algorithm which I would like to describe to you, which is called a gradient based optimization method, correct? So in gradient based optimization method, what do? We try to find out grade of f, correct? So the gradient of a function is actually grade of f, which is nothing but del f by del x1, del f by del x2 up to del f by del xn, where x1, x2, xn up to xn, they are the decision variables, and f is a function of x1, x2 up to xn. So this is clear. So this grade f is something which gives you a direction. So minus grade f is a direction of steepest descent, and plus grade f is a direction of steepest ascent, correct? So plus this is direction of steepest ascent, and if you take minus, then it will be a direction of deepest maximum or steepest descent. So what do? We start with a particular point on a surface. That may be the initial guess, because all conventional algorithms of optimization, they start their operation, or the optimization algorithm starts from the initial one, correct? So from the initial one it starts, and then what happens is that it goes like this, that it travels like the way it has been shown here. So this particular function figure shows, I think, steepest ascent. So suppose from this point you start your computation, so it will move to the another point, and we have moved locally in the direction of grade f, which is the direction of steepest ascent. Then at this point again you are going to compute delta grade f. You are moving in this direction. This is the direction of steepest ascent. Then from this point you move to this point, and that's how you keep on going, and you finally reach to the maxima of the function, correct? So there are number of theorems which talks about that how many steps are needed, not in this case, but in other case also, that if it is a conjugate direction kind of method, correct? It is a conjugate direction kind of method, which is also known as Powell's method, correct? Which does not use the differential, but rather use only the functional evaluation. So here in conjugate direction, if you move, and if it is a quadratic function, then just moving along two conjugate directions, you are going to reach to the maxima or minima. That's the kind of mathematical advantage which you get if you have a quadratic function, and in a very simpler way, in two searches only, you are able to reach to the global optima, that is global minima or global maxima. So this particular slide now talks about how to calculate the gradient, correct? So for calculating the gradient of a function, what do? We try to use the finite difference formula. So the finite difference formula, and this particular formula from the very first principles. Either you can derive from making some geometrical figures, or you can also derive from Taylor's series. So this is how you can calculate the computationally. You can find out the gradient of any function, and you can see here that sometimes we try to find out like this, that is the central difference. So this is one side difference, and this is central difference. So this is how this central difference kind of things give you a better result, rather than forward finite difference formula or backward finite difference formula. So this is generally preferred, because in this case the order of error is of the order of second order. However, in this case it is of the first order. So that's why this is a better approximation considered for calculation of gradients in this particular context. Okay, then what we do actually, then this is the procedure which has been listed here. So you try to find out the direction of steepest descent, that is S direction, correct? And then you keep on moving with certain step, that is alpha. So you keep on moving with the example. I think I will be able to show you that how really you try to do it. So you try to find out actually this Sij. Sij is a step which you move. So like in this figure, like I start from here, and how much length I should have of this vector. This is Sij, which we try to find out from this Sij. So this is how we calculate, and we try to find out this lambda star, and this is the lambda star, and sorry, Si is the direction of steepest descent, and this is lambda star is the value of the step that makes the, or you can say the magnitude of the vector Si, which makes the function minimized or maximized along the direction of steepest descent or steepest ascent. Now Cauchy has said the method to be steepest descent, because they have introduced minus sign here, and they say that the search direction should be Si, and Si is given as minus grade Fi, and we have to start with an arbitrary initial point x1 and xi, and in the beginning we are going to take I is equal to 1, correct? So we will start with delta grade minus grade F x1 as S1, that is the first direction of descent, and then we will find out this lambda 1 star for the first case, so that I am going to get x2. So the next point I will reach, that is x2, will be given by x1 plus the step which we are going to compute multiplied by the search direction. So this is how you are going to have the next point, and you will keep on moving until you reach to the optima, and there will be a good, sufficiently good termination criteria which you are going to use to terminate your search. Am I correct? Now after this, let me talk about, so this is one example. This is an example of steepest descent method, a very simple example which I will explain to you so that you can understand the philosophy. However, Arun will show you that how you do it in MATLAB. So in MATLAB there are functions. There are functions available. You are not supposed to write your own code, and using that functions or a sort of window. There's some sort of ready-made software kind of thing that is also available in MATLAB, which is a console of optimization, that is known as toolbox of optimization, which can do this thing for you. Okay, so just hold on for a while. Yeah, just hold on for a while. Yeah. Okay, hello. So I'm coming back. Sorry for the interruption. So this is the problem which I want to show it to you so that you can understand in a better way that how really this is being done. So this is the slide which I was trying to show it to you. Is it the slide is visible to you now?
Yes, sir. So this is not full screen.
But
Full
sound
screen.
is also there, eh? Yeah. So this is the slide. Let me go back. Yeah, so slide is visible.
Yes, sir.
So you can see the example is that this is the function f x1 x2, and this is the x1 minus x2, and this is how it has been given. You can just read start, and the initial point is given as 0 0. From there you want to do it. So first thing, we have calculated the grade of f, so del f x1, del f x2. So this is how we have calculated. Very simple way of doing. But when you are doing it computationally, please mind it. You are going to use a finite difference formula to calculate this. You are not going to do it like this when you are actually doing it using programming. So this is what is something which Arun would like to tell you. Grade f1. Now at 0 0, you will calculate this. So if you write x1 and x2 both 0, you get this number. So the first search direction will be minus grade f1, that is minus of this. So minus 1 1. Now what you are going to do, you are going to search along this direction. So f x1 plus lambda 1 x s1. This is how you are going to incorporate it. So what do you get actually? You get this function converted into lambda 1 square minus lambda 1. This is how you are going to convert this function, correct? So once you convert this function like this in lambda, this becomes a simple function, and you know how to find out minima of this function. So when you do, since del f by del lambda 1 is equal to 0, you get delta 1 star as 1. So this is the step. Now once this is the step, so x2 becomes x1 plus lambda 1, that is 1, and s1 we have already calculated. So the next guess, means you have improved your solution from 0 0. You have now reached to this point, and we are moving towards the minimum direction. So now again you will repeat the procedure. So in place of 0 0, now it has become minus 1 1. So you'll again repeat the procedure. So you will calculate basically grade f2, and that's how you will do it. So you again get lambda 2. Now this time you get lambda 2 star is 1 by 5. So you will get now x3 in this case. That is x2 plus lambda 2 star is 2. So you get this number. So from now again your number has changed. You have moved to second step. So you'll get x3 now, correct? So that's how you will keep on improving the solution. So finally you are getting like this, that is minus delta 4. So since grade f4 is not 0 0, x4 is not optimum, and hence we have to proceed to the next iteration. This process has to be continued until the optima this is found, correct? So once you will get optima, the solution will not change in every iteration, correct? It will cease to that particular point. It will stick to that particular point, and then your program has to have a suitable termination criteria that you get this particular optima as a result. So you can see that there are certain settings in MATLAB toolbox which can tell you that how really you are going to talk about this particular thing. Am I correct? Now I'll talk about GA, that is genetic algorithms, which is one of the wonderful tools for optimization, and even in deep learning algorithms that are based on artificial neural network, where the back propagation algorithm is used, and the error between the target value and the value which is predicted by the neural network, that is being minimized. That is actually ideally has to be 0. So we try to actually minimize the this thing that is called least square error, that is minus of the target y minus yi square summation I goes from 1 to n, where n may be the data set point. So that we try to minimize in case of deep learning or maybe artificial neural network. So genetic algorithms are very, like when I was doing PhD, I tried to do one such deep learning problem, and that is based on ANN, and the algorithm which was used to actually train the neural network and to minimize the error was based on the genetic algorithms. So you can see I have listed several, like 6 such algorithms. One is called genetic. These are the modern optimization techniques, which are also known as evolutionary techniques. So they are genetic algorithms, simulated annealing, particle swarm optimization, ant colony optimization, fuzzy optimization, and neural network based methods. So please note that these are modern techniques. They are called evolutionary. Why they are called evolutionary? Because they are based on the evolution of evolution and based on certain natural concepts, correct? So like this genetic algorithm is based on the human chromosomes, how the chromosomes get mixed, and how the parents they mate and they try to get babies, and how really the quality of the babies can be improved. So based on that concept, actually this genetic algorithm has been developed. I will tell you the details in my forthcoming slides about genetic algorithms. Simulated annealing is something which is based on the annealing process. Because I believe most of you may be mechanical engineering and you know what is annealing. So annealing is basically a stress relieving process, correct? So here stress is nothing but error, correct? So we try to minimize. So I am not very much aware of this. Then similarly, particle swarm optimization. This is again PSO. PSO is a very popular algorithm. Those who are interested, they can read their own. I am not going to talk about it. This is very nicely used in various even the management tools, correct? And I believe that there may be a toolbox for PSO also in case of our this thing methodology, in case of our MATLAB tools. Then similarly, ant colony, like what is the motion of ants? You might have seen that these ants are move in a very systematic manner. They follow each other and they can even climb, and sometimes they optimize in such a way that they can do a very Herculean task also. They can sometimes lift a load which is more than them, correct? So that's with those concepts something has been done. Neural network I have already talked about. So my focus is, because I have worked a lot on genetic algorithms, so I'll try to introduce in 5-10 minutes, I'll try to some idea about genetic algorithms, and Arun will again show you the toolbox of genetic algorithms, and he will show you the live examples that how really you can optimize some functions which are based on simple functions or very complex functions, multimodal functions with constraints, etc. Now, before really moving ahead, I would like to tell you that this traditional method, I have first talked about the gradient-based method or conventional algorithms, correct? So this evolutionary algorithm like GA and the traditional algorithm like steepest descent method, which I have talked about, how they are different, correct? How they are different, and what are the advantages of GA kinds of methods over traditional methods. So one thing is that like in traditional method, we start with only one initial guess, but in genetic algorithm or in other methods also, there's a set of initial points. There's a population of initial point, which is trial design vector, which is also called initial population in the language of genetic algorithms. And genetic algorithms use only one objective function. The derivatives are not used in the search procedure. So in GA, we don't use like grade F kind of thing, correct? Now in binary GA, actually we use binary coding of the various decision variables, and which corresponds to chromosomes in natural genetics. So basically 0 and 1, when you convert a number to a binary number, basically it is a combination of 0 and 1 only, correct? So you will be able to handle the situation like that. Now the objective function value correspond to a design vector is known as fitness value here in case of genetic algorithms, and these algorithms are very well suited for a multi-objective optimization kind of problem. Like you will find that the conventional or traditional methods, they are not good when the problem is multimodal in nature. So if problem is multimodal in nature, you will find that you may get stick to a local optima, you may get stick to a local minima, you may get stick to a local maxima, and you will not have any idea about the global maxima or global minima. But in case of these evolutionary algorithms, you will find that you will reach to global optima, that is global maxima or global minima. There are certain ways here. Everything I cannot tell you in that short lecture, but obviously these MATLAB tool, which Arun is going to demonstrate to you after my talk, he will tell you that how really you are reaching to the global. So what do we do in this case? Like this is how we code our, in case of genetic algorithm, this is how we code our decision variables like x1, x2, x3, x4. They are there. So they are coded like this. They are coded in binary numbers, like in the form of 0 and 1. So that's how they are being coded, correct? And they can be decoded by this simple formula. You know how to decode a binary number. That's a very simple thing. Sometimes it is taught in class 10th also, 9th, 10th also, and maybe in computer science course in BTECs also. So it's a very simple way of decoding a number. And then basically this formula tells you like it is a division, because more bits, like x1 has been represented by 1, 2, 3, 4, 5 bits, correct? Now if I represent, suppose x, like x2, you can see x2 is also represented by 5. So in this picture, all x1, x3, x4 are represented by 5 bits. But suppose I represent it with 6 bits, 7 bits, 10 bits. Suppose I take 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 10 bits I make. Now if I make 10 bits, what will happen? That the accuracy of the x4 will increase, correct? Because in this case, I am dividing the range of x4 in 32 parts, because 2 to the power 5 is 32. But if I make it 2 to the power 10, you can understand that how many divisions I am doing. So the accuracy of the solution will become very high. So basically the decimals value you can obtain from this, and this is how you can, you can map the particular bit byte to a particular decision variable number. This talks about what delta x, that is the accuracy level. So if delta x the accuracy level desired, then what is the binary representation? How many bits you need, that you can determine by like this. That suppose if you want this much of accuracy and with bounds 1 to 5 of x, then you need to have actually q is equal to 9. So with 9 bits, 0, 0, 0, 1, 0, 0, 1, 9 such things, you will get an accuracy of 0.01 order. That's what is the meaning of this bit. Now in case of a genetic algorithm, actually we try to represent the objective function as a fitness function, correct? In case of because if how fit is a particular solution to a particular optimization problem, so that's what we call as fitness function. So if it is a maximization problem, fitness function is same as the objective function. However, in case of a minimization problem, the fitness function is defined as 1 upon 1 plus fx. So if fx will be maximized, capital Fx will be minimized. You can see it's a very simple mapping. Is it clear to everybody? I believe you can appreciate this particular thing, that if you maximize small effects, then capital effects will be minimized. Is it okay? So very simple mathematics. Okay, so this I have already explained to you, that this is a general optimization problem which has constraints, inequality type of constraints and equality type of constraint. Now in case of GA, or even in case of conventional optimization also, sometimes or we use a penalty function approach to convert this problem into a single objective problem. So you can see what has been done. Fx I am putting here plus gx, and gx has some typical kind of bracket, these kind of brackets, correct, square. So that what it is mean, that if gx is greater than 0, then I am taking same number, but if it is less than 0, then I am taking it 0. What does it mean? If gx is less than 0, means my constraint is satisfied, so I'm not bothered. If gx comes less than 0, I do not have any problem, so I'm not penalizing. Okay, try penalty function means I'm giving penalty. So because I want to minimize effects, I am adding something to it. So if it is a minimization problem and I'm adding something, means I'm penalizing. So I'm not penalizing if gx is less than 0. So it has become 0. Otherwise, it is equal to gx only. This is the meaning of this particular sign. And we are squaring it because sometimes it may be negative, correct? And we are doing it for all m constraints. Now, for equality kind of constraint, we are simply, because if hx is exactly equal to 0, there won't be any penalty because this will become 0. But if it is non-zero, whether positive or negative, I'm squaring it and adding it to the function. So there actually we are penalizing, and we are actually multiplying it with this constant Ri or capital Rj, because we want to multiply it with some constant in order to make their orders same. Like मान लीजिए ये लाखों की नंबर्स में है, लाखों में है, और ये दशमलव में है, तो इसका कुछ असर ही नहीं पड़ेगा. Is it clear? It is in lakhs and it is in decimals, so it will not penalize. So in order to make their orders same, like if this is of lakhs order, this should also be made lakhs order. So that's why this constant has been multiplied. This has also to make a lakhs order. So this constant has been multiplied. Suppose this is weight and this is surface quality. Now surface quality will be in microns and the weight will be in kilos or tons. So if you add something, nothing will happen. So that's why you will make Ri to be as say 10 to the power 9, so that this also comes in the order of this number. I believe this is clear to everybody now. Why these constants Ri and capital Rj, they have been multiplied here, correct? So then we are going to calculate basically the fitness function for a minimization problem like this. If it is a maximization problem, this definition is only for minimization problem. Okay, then in case of GA, actually we have 3 genetic operators, correct? These genetic operators are called reproduction or selection, crossover and mutation. So I'll tell one by one. So first one is called reproduction or selection, correct? So in the beginning, what you do, you create an initial population, correct? So initial populations are created, and then you try to do a selection. Selection means randomly you will choose maybe 2 or 3 strings, and you try to find out the better strings and you replace it. There are various kinds of reproduction or selection operators. One such operator, there's one called roulette wheel selection. There's one called stochastic remainder selection. So different kinds of operators have been designed which select actually the best string out of the set of few by comparing few. There's one called tournament selection. So roulette wheel selection, stochastic roulette wheel selection, and tournament selection. These are three I have named you, which are the selection operators which are done through this method. Then crossover. Now in crossover, we try to actually mix the strings, correct? How do we mix the strings? Like this is a parent string. This is another parent string, parent 1, parent 2. And this is a site, mixing site. So now you can see this portion has come here and this portion has come here in children's. So in children, this portion has gone up, this portion has come down. So you have created new strings for the next population, correct? So this is called a crossover. Is it okay? So crossover is done for a good amount of probability. That may be, the probability may be of 0.8, 0.7, something kind of probability we do the crossover. We don't cross entire population. Then what is mutation? Mutation is something. What is mutation? We nowadays we say COVID. This coronavirus is mutating, very frequently. What does this mutation means? It is the same mutation, correct? Which is a biological process and a natural process. So what is this mutation is? Mutation means if something happens to your DNA suddenly, naturally, there's no cause for it, correct? So that is called mutation. So the because of crossover, in crossover you try to mix the properties, but in case of mutation, you try to bring diversity in the population, correct? So what do you do? In mutation operator, randomly one of the bits is either converted from 1 to 0 or from 0 to 1. So what do? You bring diversity in the population. That's what the meaning of mutation, correct? So values are created. The crossover is the main operator by which new strings with better fitness are created. However, in mutation, what do? We apply this 1 to 0 or 0 to 1 with certain probability, and mutation is done for a very low amount of probability, maybe 5%, 10%, 15%, but crossover is done for maybe 85%, 80%, something of that kind we try to do, correct? Then actually there's an algorithm for it. So what we do, we create the initial population and we do the selection, we do the crossover, we do the mutation, and then a new population is generated. We try to calculate the fitness function and try to see that how much good strings they have been produced, and they will actually improve over the generations. So generally, when the maximum one so generally in case of GA, the termination criteria of program is either the maximum number of generation reached, or when sometimes the average population or average fitness does not improve above certain level, start oscillating, or it tries to saturate. That's how we try to fix the criteria for termination in case of genetic algorithms. So you can see that I have tried to cover the conventional way of algorithm and the genetic algorithm part, which is an evolutionary algorithm, and I have tried to give you a feel that in what kind of problem what kind of algorithm will give a better result. Though there are variety of methodologies, there are variety of algorithms, there are variety of ways to solve it. So sometimes the success of your solution depends on the kind of objective function you are having. If the objective function is very complex, sometimes you may face some problems. But evolutionary algorithm will definitely give you some solution. So we do number of trials, number of times we run the solution in case of genetic algorithms to get a confidence that what optimum solution we have obtained is really a good optimum solution for us. And please mind it, there's no mathematical proof for evolutionary algorithms, or typically in the case of genetic algorithms. So we do it, and they are very successful, and there are toolbox in MATLAB. So if you have any question, it is already 10:50. So In 5 minutes, we can take some questions, and after that, there will be a 30-minute session by Arun, who will show you all these algorithms being run on MATLAB. So you can now I think organizers can take some questions, and they can I would be happy to answer the questions. Yeah.
Dear participants, if you have any question regarding the talk till now, you can post it on chat box. So I think there is no question.
Okay, so then if there's no question, there may be break of 5 to 10 minutes, and at 11 o'clock, I think Arun will resume. Arun, are you listening me?
Yes. Yes, sir. Yes, sir.
So you can set up your things, and you can start one by one from the very simple problem in MATLAB, and you can tell 4 or 5 problems, and also you can demonstrate GA. You have actually around 25 to 30 minutes time, so you can complete the things. And I'm here. I'll be watching everything, and if there's any need, I will answer the questions. Is it okay with everybody?
Yes.
Sure, sir. Sure, sir.
Yeah.
Sure, sir. So, dear participant, we are taking 5 minutes break, and we will resume the session at 11 a.m.
Yeah.
A nice session.
Arun.
Hello. Yes, sir.
Arun, you can start now.
Okay, sir. Sir, is my presentation visible? Hello.
Yes, visible.
Okay. So, good morning all. My name is Arun, and I would like to start with a brief introduction to MATLAB. We will be doing our programming on MATLAB only. So MATLAB is a toolbox or is a software in which we have a function of we can write our programs in the script file, as you can see here. This is the default view of the MATLAB window. So whatever program or whatever codes we write, we can save our file in the form of a script file, as you can see here, and the results or the final output will be seen in this command window in the form of output or in the form of graphs and other things. And these variables will be, for a short term, will be stored in this workspace, as you can see on the right hand side. So these are some basic commands. So unlike C and other hello.
Arun,
Yes, sir.
आप अपना स्क्रीन तो शेयर करो. स्क्रीन आपका बहुत छोटा सा आ रहा है.
सर एक्चुअली किसी और ने शेयर किया था इस
Actually, pin the slide of Arun.
सर now is it visible?
नो, दोबारा से करो फुल स्क्रीन.
अरुण कुमार. Yes, it is coming. Sir, Abhirat sir अब आ रहा है.
Okay. No, actually, if there is any problem occurs, just pin the presentation of Arun. It will come to your screen.
Someone is trying to present something.
If any interruption occurs, then pin the slide of Arun.
Participants are requested not to share anything. So due to that, Arun Kumar is not able to show his slides properly. So you all are requested not to interrupt in between. Okay, sir. You can continue.
Okay, sir. So these are some basic commands. So unlike C language, here MATLAB identifies the input. We need not to specify whether this is an integer type of variable or a float type of variable. It automatically deciphers it. So these are some basic assignment commands, such as we are assigning the numeric value to a variable A, and similarly to a variable B. And these are some simple mathematical operators, that is A raised to the power B, or A addition to B, or A multiplication B, or division. So these are some basic commands we will be using in our MATLAB programs. And in MATLAB, everything is in the form of matrices. So we should know how to input our matrix in the command window. So these are some 3 different types of matrices. So first one is a 3x3 matrix. So we separate the row elements by a space, and then we separate the second row by a semicolon. So in this way we can input our elements. And the most important thing in the MATLAB is that there are 2 types of multiplication. So one is a simple matrix multiplication. I have defined 2 matrices, A and B, as you can see on the screen. So if we simply write A into B, so this will be a simple matrix multiplication operator. But if I write A dot, then multiplication operator, and then B, then this will be element-wise multiplication. So as you can see, each element of A is multiplied with the corresponding element of B. So this kind of things are normally used in MATLAB programming. So this thing we have to keep in mind. How we widely use functions to reduce our work, so reduce our program. So I am showing a simple program in which we are calculating the volume of a cone. So here are 2 basic inputs, the radius and the height. So this is the way we write our program in the MATLAB. So we have to define a function. So as I am defining a function named b, so I have to specify first what is this. So this is a function. Then this will be my output. So my output will be in the form of a alphabet b, and then short description of the program, and then what will be the input. And then I will save my program with the same name as of the description. And then these functions can be called back in different programs to save our programming space. So in this, I have shown a simple program in which I am recalculating the volume as my radius and my height are increasing by a factor of 3 and 9. So and this is the output. So we need not to write the same command, this same command again and again. So instead of writing this command, we have input a loop, a for loop, and this function. Now, as sir has described the optimization, so we will be seeing simple examples of these optimization techniques. So starting with the gradient descent method. So I am taking a Rosenbrock function. So this is a Rosenbrock function in which the values of a and this b are taken as 1. So on the right hand side, you can see a 3-dimensional plot of this function. So we are trying to find the minimum of this function using a gradient based method. So if we plot it on the left hand side, you can see the coding for the contour. So this right hand side, this is the contour plot, and this red mark is the initial guess for our solution. So we are using Cauchy's algorithm of steepest descent method. So the first thing we require is an initial guess. So I'm taking my initial guess as x is equal to 2 and y is equal to 2, so which has been plotted here. And I will be updating my, so first of all I need to find out the gradient. So this is a simple code for finding out the gradient. And based upon this gradient, I will be updating my x and y. But what step size should I take? So this d is the step size in the direction, in the steepest direction. And this d direction, how this function, my objective function, so this is my objective function. So how this function is varying with different step size, this is shown in this graph, you can see. So steepest descent, we have to find out the optimum value of this d, so that the function value is minimum for that point. So here the minimum value is around here. So I'm using a simple MATLAB command fmin search to find out the optimum value of this d for which the output is minimum. And after finding out that optimum step size, I will update my initial guess. So this is the updated guess, the point shown in blue. This is the updated guess. So in this way, we will keep on
Hello. What is EZ plot here?
EZ plot is a command to plot the function. So BD is this is the function BD. I am calling this function. So between this range, between 0 to 0.1 domain of D, this is a function of D only. As you can see, BD @D. So this is a function in terms of D. So for D varying from 0 to 0.1, how my this function is varying, I can show it using this plot, easy plot. Hello?
Okay, sir.
Fine. You can continue.
Okay, sir. So let me demonstrate another example for this. So I'm taking a simple function here, 2x1 square plus x2 square. So is this graph visible to all?
Yes.
Okay, this is the 3D plot of the function which I have taken, 2x1 square plus x2 square, and the lines on the xy plane are the contour lines. So I'm trying to find the or optimize this function using gradient based method. So this is the visualization of the program, and now I will see how my point is moving. So this is the updated, the position is being updated at each iteration. So these are iterations going on. This is the contour plot, and this point is moving towards the optimum position. So based upon the stopping criteria, I can choose different stopping criteria to find to stop the iterations, and in this way the program runs. Our position keeps on updating based on the steepest descent method. Now we need not to write big programs for this. MATLAB has some inbuilt tools, so we will be focusing on those inbuilt tools. So what are the requirements for using those toolbox? So first of all, we need to understand the problem given. So the given problem will have three components. First of all, we need to identify what will be our objective function, which we have to minimize or maximize. Then what are the constraints given? And then what are the bounds on the variable? So this is a representation of the problem. So we will have some function fx, and then we will have some inequality, non-linear inequality functions, some equality non-linear functions, some linear inequality functions in this form, and then some equality linear functions, and then some bounds. So we need to identify this C equivalent A, these types of variables for using in the for the toolbox. So I'm again using this Rosenbrock function, but with different values of A and B, as you can see here. So this is the visualization of the problem. So this is the how a function looks like, and this is a simple MATLAB program to load this function. So the first step is to define the objective function. So this is my objective function, and I'm writing a simple program and saving my output in the form of fun, and taking two variables x2 and x1. And then MATLAB has a toolbox known as optimization, as you can see the toolbox in the red circle, and it has different algorithms available, as you can see here. So among this we will use according to our problem. So first of all, we will be looking at unconstrained minimization when there are no constraints on the problem. So among the different algorithms available, we will be choosing fmin unconstrained. And then this is the toolbox, how the toolbox looks like. And the first thing that we have to input is the name of the program we are running. So I have saved my objective function in the form of this example. This is the name given to the program. I am calling back this my program by an operator @. So @ example is calling the function, and then we require an initial guess. So I am taking my initial guess as -1 and 2, and then I will start. If I click on the start, then my iterations will start on running, and after some point they will stop. And this final point is the optimized values of x1 and x2, number of my variables. Then there may be some constraints in our problem, so we will be using fmin constraint. So let us start using different constraints. So first of all, let us take an linear inequality constraint. So this type of constraints will be in the form of ax less than equal to b. So this is the example here. I am taking a variable of x1 plus 2x2 less than equal to 1. So by comparing these two equations, I will be identifying what is the value of a and what is the value of b. So this is I have done here. So this is my a based upon comparison, and b, and x0 is my initial guess. So I will be putting this is my input to the toolbox. So among the algorithms, I have chosen fmin_con. I have called back my function. This is my calling back, and then my starting point or initial guess. And then earlier you see that there were these were all empty matrices. these were all empty. But now, as we have linear inequality in our problem, so we will be writing the value A from here and B from here in this toolbox. And then I will start my algorithm, and after some iterations, so here it took 20 iterations to solve this, and this is the optimized value. This is the optimum value of x1 and x2. Now adding one more constraint. Now we are adding an equality type of constraint. So this is the equality type of constraints I have taken. And again, based on comparing these two equations, I will be finding out the value of A equivalent, B and B equivalent. So these are the input available or based upon comparison. And this is my initial guess. So I am inputting this into my toolbox. So again, choosing fminCon, calling the objective function, choosing the initial point, and then adding or inputting the value of A, B, and one more inequality is there, equality is there. So adding those values. And as there are no lower bounds and upper bounds, so we are keeping these matrices empty. And then I will start my algorithm. And after some iterations, I will have my optimum value here. Now there may be some non-linear constraints also. So what we have taken here is that we have to minimize our problem within a region defined by a circle having a center at 1/3 and 1/3 and a radius of 1/3. So I have defined this non-linear constraint using this function. I have defined one more function here, circle constraint, and then this is my non-linear constraint C, and defined in a mathematical form. And if there had been a equality type of non-linear constraint, then I have saved that in this. But in this problem, we have not considered any equality constraint, so we will keep this empty. And also, we are taking some bounds. So we are defining some region of interest for x1 and x2. So x1 varies from 0 to 0.5, and also x2 cannot increase, or x2 varies from 0.2 to 0.8. So based on comparison, we can identify our input. So this is my initial guess. So again choosing, this is the toolbox. In the toolbox, I am again choosing fminCon, again calling back my function, giving the initial point, and here this is the non-linear function which I have described earlier. I am calling back that function. This is the name of the function, and @ is the operator for calling back. And as we have given some bounds, so this is the lower bound for x1 and x2, and this is the upper bound for x1 and x2. And then I will start my algorithm, and after some iterations, I will have my optimum value. So this is the optimum value for x1, and this is the optimum value for x2. Now moving on to genetic algorithm. So as sir have described earlier, this is a algorithm inspired from biology. So what is the key advantage here is that unlike previous algorithm we have seen, which they require an initial solution, we start with a population of solutions. So there are multiple points of start, and also, so because of these multiple solutions we are taking as an initial solution, so there are less chances that we can get trapped at a local optimum. So the key advantage of this technique is that we will have a global optimum. And also this approach is not dependent upon the derivatives of the function. So let me describe this genetic algorithm toolbox using a simple example. So what we have considered here is a rectangular prism type box, and we have to find the value of this x1, x2 and x3, these three variables of length, width and height for the largest volume. But there are some constraints given to this problem. So what are these constraints? That the sum of the this length, width and height cannot exceed 60, and also there is some constraint on the variable x1, and this is the minimum value we have to consider for all these variables. So So in a similar fashion, first thing we need to do is define our objective function. So I am defining my objective function with the name of volume of prism in this way, and saving my output in the form of V. So, but the one thing we have to consider is genetic algorithm toolbox in MATLAB only minimizes the problem. We cannot maximize it. So for maximizing, we have to find an alternate route. So in this problem, we have considered intermediate function V1, which is the volume of the prism, and then I have defined an objective function V, which is of minimization kind. I have to minimize this V, but this V will be minimized when V1 is maximized, because I have taken the reciprocal of this function. So again, we have to identify our inputs. So A, B, and bounds as shown in this screen. This will be the toolbox here. So the toolbox will look like this. And from the different algorithm available, we will be choosing genetic algorithm. And after choosing the solver type, we will call back our function. So this is the calling back of the function. And we have to define number of variables. How many variables are there? So in our problem, we have 3 variables. Then what are the inputs, different inputs? What are the bounds? So after inputting that, we can start our solver, and after some iterations, it will give us the optimum value. Now, our objective can be a single objective problem, or it can be a multi-objective optimization problem using genetic algorithm. So first of all, considering single objective function. So taking the Rosenbrock function once again. So this is our objective function, and we have to minimize it. Subjected to different constraints, as we can see here. So there are non-linear constraints available, and there are some bounds there. So once again, defining our function. This is my objective function, and saving this as func1, and then defining my non-linear constraint function. So saving my non-linear constraints in this form, and then identifying different input parameters, and then using GA toolbox in a similar way. First of all, choosing the solver, calling the function, how many variables are there in the problem, then your input parameters, bounds, and then non-linear function. And similar to previous problem, we will start our algorithm, and after some iterations, we will have our optimum solution. And now let us consider a multi-objective problem. So in previous problems, we have considered only single objective. We have to either maximize or minimize only single objective. But here we have a problem in which we have to minimize 2 functions together. So these are my 2 objective functions, as you can see here, and we have to minimize these. So in the same toolbox, there is a solver known as genetic algorithm multi-objective optimization. So using multi-objective optimization solver, we will call back the function in a similar way. We will input on how many number of variables are there, input different parameters, and we will start our problem. And after some point, in earlier problems, we had only one solution, one optimum condition. But unlike single objective function, multi-objective function will not have a single point or for maximum or minima. It will have a number of points on which the optimum solution will lie. So we will call that as a Pareto front. So this toolbox has that facility it will provide you the Pareto front along with the optimum solution for this. So this is the optimized value of F1 and F2, and this is the Pareto front of different values of X1 for which are lying on this Pareto front shown in this pink stars. Now what is a practical, now let us consider a simple practical example for genetic algorithm. So this is a welded beam problem, and we have to there are some parameters over the weld parameters which are considered here, and we have to find the optimum weld parameters so that the cost is minimum or minimum cost. And these are subjective. So they have in the problem they have 4 input parameters, and they have defined objective function or the cost function in this way, and these are the constraints given. The details of the constraints are here. So you can see in this way we can optimize the weld parameters for a minimum cost. So this is a practical example of the genetic algorithm. Also, we can use genetic algorithm for DOE in combination with DOE. So let me show you one example.
Hello, Arun.
Yes, sir.
I think the time is completed. You can leave this. At any other time you can do. You can. Aviral, are you there?
Yes, sir. Yes, sir. Yes,
So
sir.
we can stop now.
Sure, sir. Actually, Pawan
Do you
sir,
have any other speaker also scheduled, or you have time?
no, sir. Pawan sir already joined us, so he has.
Okay. Okay. Then time is completed.
Yes,
I
sir.
think you can email me if you have any question on this session, because we have already completed and exceeded the time. I'm telling to all the participants. So let the other speaker can start their presentation. So thanks a lot. Thank you very much. Huh? Is it
Thank
okay,
you, sir.
Aviral?
Thank you, sir. Thank you, sir. Thank you
sir.
for giving such a detailed explanation how to handle it with the software. I think it really benefit the participant for varying problems. Thank you, sir. Thanks a lot, sir.
Thank you, Arun, for helping me in organizing this session. Thanks a lot.
Thank you, sir. Thank you, sir.
Sir, thank
Thank
you.
you,
to
all. Dear participant, we have been joined by Dr. Professor Pawan Kankar from IIT Indore. Let me see he is here or not.
Yeah, he's there, sir.
I'm not able to. Yeah,
yeah.
sir, is I am audible, sir?
Yeah, loud and clear, no issue.
Okay, thank you, sir. So, Dr. Pawan Kankar, sir, is from IIT Indore. He is working as an associate professor over there. Sir, I am introducing you first with the participant. Then I will hand it over to you.
Sure.
So he is an associate professor in the discipline of mechanical engineering. His research interests include fault ability, biomedical signal processing, and analysis of dynamical system. He is more than 15 years of experience of teaching and research. He worked with Villanova University and United Technology Research Center in USA for effective discrimination between 4 kinds of common defects in gears by utilizing the method of recurrence analysis. Dr. Kankar also worked on improving theoretical model of unbalanced shaft bearing system with researchers of Faculty of Science, University of Yaoundé, Cameroon. He contributed in various projects awarded by national and international funding agencies under Imprint India initiative by Ministry of Human Resource Development and India-Japan Cooperative Science Program, etc. That total worth of that projects are rupees 3.3 crores approximately. Dr. Kankar has established Machine Dynamics and Vibration Lab, UG Computation Lab in IIIT-DM Jabalpur. Actually, he is working previously in IIIT-DM Jabalpur. Now, for 1 year, I think he has joined IIT Indore, where also he has developed System Dynamics Lab He organizes various short-term courses, workshops, and conferences for skill development of students, faculties, and participants from the industries. He has till now he has supervised 6 PhDs, 16 MTech students. He served as guest editor for special issues of Advances in Mechanical Engineering on advanced signature analysis for machine fault diagnosis and prognosis in the year 2019, and lead guest editor for special issue on International Journal of Rotating Machinery on fault diagnosis and prognosis of rotatory machinery, also in the year 2017. He has actually 100 publication in various reputed journals, conferences. He is a fellow member of International Institute of Acoustic and Vibrations, USA. He is also a member of ASME, Society of Reliability and Safety, Tribology Society of India, and his total citation being counted is more than 2000. So I would like to request Dr. Kankar to start the session. So please,
Yeah.
you can start the session.
Thank you. Thank you, Dr. Mishra. Thank you very much for a nice introduction. And today we are going to have application of machine learning in the domain of mechanical. Then I will be discussing that, okay, how we are going to use these machine learning in other domains as well. Okay, so how you can do in the manufacturing, how you can use it in product design. So other domains, how we can use it in effective way. So that we are going to cover today. So let me begin with my presentation. Just a moment.
Sir, present now option is there. Present now.
Yeah, present now I know, but actually that PowerPoint, it was not showing in that. So just I was looking for that, how,
Okay.
why it is not. Yeah, now it's coming. Yeah. So am I audible to everyone? And
Yes, sir, it's fine.
and slide is also there. Can you see my slides?
Yes,
Can
sir.
you see my slides?
Yes, sir.
Yes, sir.
Yeah. So today we are going to talk about machine learning techniques and its research application in domains, different domains, including mechanical. So first of all, let us understand that what do you mean by machine learning techniques, why we need it, and how we can use it. So machine learning, when we talk about it, is about making machine learn through certain algorithm. Okay. Now, why we want to do that? That is important because at present, whatever we do, we are going to have a decision-making power in any application. So that human is involved everywhere in decision-making, and they are taking some decisions, and that decision is going to impact on the production line, maintenance decision, and many others. So what we want to do that, again, human beings are having their own capabilities. So we want to have a machine which is able to take decision irrespective of the time, hour, and they can take a decision in a consistent way. That decision is not going to be affected by like day or night, your mental status, and many other things. So let us understand that. So conventionally, if we talk about, we are having human experts. So I'm having an expert of the lathe machine or the shaper or CNC milling or whatever it is. So I'm having some human experts. Those are working on those machines. They are continuously analyzing the data we are getting from these machines. They are continuously monitoring that data and trying to identify, yes, if there is an ambiguity in that. Or suppose I'm working on a CNC milling machine, and if I find that there is some rough surface is coming, so I may be changing my tool, or accordingly I may take that, okay, I need to stop my operation, then I need to see that what is the problem, or there is a misalignment in the spindle or something like that. So human is continuously intervening between the process, and according to the decision of that human being, we are going to perform machine process monitoring or condition monitoring. So we can change our process, we can observe our process, and we can also do this maintenance task. So we are having this kind of flow. Now, why we want to have? Because human, as I told you, human to human things are going to vary. Their expertise, their opinion may vary. Like even if we are going to doctor, one doctor may be saying, okay, this is the problem of headache because of this problem. Another doctor will be saying, no, this is not because of that, this is because of some other reason. So every human is having different perception about the situation. So we want our machines to learn from different cases, and that is going to impart or taking part into the decision making. Now, how we are going to give this decision making capability to machines? So for that, we need to first understand that how we are saying any human as an expert of that field. So human beings are called as expert of the field based on their knowledge. Okay, now when we talk about their knowledge in the particular field, we are talking about the situation in which a person is having in-depth idea about that particular problem, and to get that in-depth idea, they are having master's degree, they are having graduate degree, they are PhD in that particular domain. So basically they are acquiring knowledge through the learning. So continuously they are learning from the different situations, they are taking example, they are conducting some experiment, they are doing some theoretical analysis, and based on that they are getting that knowledge to make certain decision in some situation. So same way, machines need to acquire knowledge from the surroundings. They need to learn from the different examples. Okay, so those examples we need to provide to the machines, so that is going to be synthesized by these machines through the certain algorithms. So these algorithms like support vector machine, artificial neural network, deep learning methods, all these are the algorithms which are making these machines to learn from the different examples. So when we talk about any expert system, attempt is made to develop an algorithm on the basis of human expertise which is available. These are often considered to be one of the most popular application of AI techniques. So this is going to be used in different situations for decision making. The subfield of AI is the machine learning, where we are designing and developing algorithms which will allow computers to learn. So in that way, our computers are going to acquire continuous knowledge. Okay. Now, when we should use them, what are the possible application? So first of all, we need to understand that nowadays ANN, support vector machine, or any AI techniques, these are very buzzwords, and most of us are using them for different applications. Definitely you can use them for any application, because you are having good computers, you are having good computational capability, you can do it, no issue. But you see that, like, I am a teacher. So as a teacher, it is better to give me a task related to the research or teaching, rather than giving me some task which is totally irrelevant to me. Okay. So in the same way, we can give different tasks to these machines, but they are for a specific purpose. So while giving any task, while using these AI techniques, we should be very careful. So when I should use them, that is very important to understand. So I will come to that. Before that, let us see some of the examples. So one of the example is handwritten character recognition. So handwritten character recognition, we can use these machine learning techniques. Now, in handwritten character recognition, what is the challenge if I look at this? Because challenge is there, because I am writing in a different way, any alphabet, it may be A, B, C, whatever it is. You are writing in a different way these alphabet. That's why we are using our biometric signature. Whenever we are using our signatures or the different biometric devices, we are writing something that is unique in nature. That's why even banks are using our signature for identification of the person. That means every person is writing these characters in a different way. So it is challenging that you may be typing in a different, you may be writing in a different way, I will be writing in a different way. The size, inclination and other characteristics of those alphabets will be very, very different. So that kind of uncertainties, which is very difficult to quantify, that I cannot say that, okay, when you are writing A, this should be dimension, this should be inclination, and that kind of nature will be there. Okay. So in that case, a lot of uncertainty is there. Every person can write in a different way. So on those kind of uncertain environment, you should use machine learning techniques, which will be taking certain features of these character and it will be able to recognize these characters. So nowadays we are having different softwares which can read your slides or the handwritten notes, and they can convert into the alphabets, corresponding alphabets. So these kind of techniques are behind that. Then when we are talking about these examples, basically we are talking about synthesizing program, which is known as learning methodology. So we are having methodologies which are making them learn. Then we are having output, which is corresponding to given set of input, that is known as target function, which is going to map this input to the output, that is known as target function. Now these learning algorithm, whatever output they are giving, that is going to be considered as a solution, and the function which is relating this input to output, basically that is going to be decision function in case of problem is classification problem. Now this is very typical word, classification. Now these can be classified into the we can say two parts: classification problem or regression problem. As I was talking about that, okay, whether alphabet is A or B or C, I am classifying into the different category of alphabet, so that is known as classification kind of problem. For example, I am taking a satellite image and I am trying to identify at that particular location whether there is a water or not. So that kind of situation is classification, that whether there is a water, whether there is no water. So I am classifying into the two situations. So these problems in which we are classifying them into the category, that is known as, in that case the function is known as decision function. Now if we look at this machine learning application, there are other applications in different domains. So first is the pattern recognition. What do you mean by pattern recognition? What do you mean by pattern recognition? Pattern recognition, like we are doing in our mobiles, we are using our thumb impression for getting access to our mobile. So basically when we are doing that, we are checking the pattern on our fingerprints, that okay, how, because we know that everyone is having different fingerprints, so we are identifying those patterns. Even another example, face recognition. When we are using our device, face is being recognized by our mobile device or the laptop device, and based on that we are going to identify whether you are authorized to sign in that device or not. Similarly, you are using Alexa, you are using Google Assistant. So there are various speech recognition softwares which will be addressing your commands, and accordingly they will be doing this exercise. So we are having a speech and handwriting recognition. Then comes medical diagnosis. In case of medical diagnosis, various applications include, like we are having cancer detection in different applications. We are having brain problem detection that we can also do, that Alzheimer detection that we can do, Parkinson detection we can do. So there are various diagnoses possible for the medical application, that may be including different domain expertise. So first of all, we may be having MRI, we may be having CT scan, we may be having many other things for this particular kind of application. Next comes fault diagnosis. Fault diagnosis is mechanical application when we are trying to identify faults in the machines. So these machines can be of electrical nature or mechanical nature. So we can have faults in machine through these machine learning algorithms. So we can identify them. We can identify the component as well. So that kind of application is also possible. Then comes stock market analysis. Stock market analysis, we know this is again having lot of uncertainties in nature. So we are having the condition in a stock market when there is a small statement by any of the leader, maybe Trump, maybe Modi ji, that is going to affect the stock market in a larger way. If there is a disease like COVID situation, we are having again the different kind of scenario in this case. Then these kind of uncertainties can be handled by the machine learning algorithm. Then classifying DNA sequences, we can also use in the biomedical application like DNA sequence classification, or nowadays we are having autonomous vehicles commonly used in many advanced or developed cities, where we can use computer vision to identify other objects. So all these kind of applications are there. Now if I look at all these applications, what is the common in them? These are from different fields. These are very complex in nature. But similarity is that these can be having the problems which are having lot of uncertainty. So whenever there is lot of uncertainties in the system and your output is dependent upon many more inputs, there are a lot of inputs available on which your output is dependent, then you are going to say, yes, I need to use machine learning algorithm. Remember that there can be application of machine learning algorithm in the simple problems, like I can have a simple data like coordinates, XY coordinates, maybe 1, 1, 2, 2, 3, 3, 4, 4, which is the equation of x equal to y, right? So I can relate this. X is what? Our independent variable. Y is what? Dependent variable. So y is equal to x when we are talking about. Y is our dependent variable, which is dependent upon the independent variable x. So I can have this kind of situation in which I can have a clear-cut mathematical relation between the input and output. So in these situations, we should not use these machine learning algorithms. This is very, very important. Try to understand that when we are having physics-based model, when we are having mathematical based model, deterministic model, we should use them rather than using machine learning algorithm, because they are giving you tentative answer based on their learning experience. They will not be giving you exact answer sometime. So if you are having physics and mathematics based model, you should prefer them. If there is lot of uncertainty in the system, difficult to relate various inputs to the output, then you can use machine learning algorithm. So this is very, very important point. I request you all to remember this point, that you should use machine learning algorithm only when there is some kind of uncertainties in the system or the non-linearity in the system. Now, when we talk about the learning, and we are developing algorithm to learn from the examples, synthesizing those methodology examples, then we are having three kind of mode of learning: supervised learning, unsupervised learning, reinforced learning. When we talk about the supervised learning is related with the condition when we are having input and output set both available to you. Okay, we are having both set of input and output available for the learning. As I was talking to you, for example, I am having the condition that, okay, this for learning, I am having image, I will be saying that this is water, this is other than water, this is water, then other than water. So I may be having this kind of 100 images which may be corresponding to water and other than water situation. So all those kind of conditions will be considered as a supervised, where input and corresponding output both are given to you. Second situation may be unsupervised learning. No output is available. We don't have any kind of output. So that kind of situation may be there when we are having a very new system, a breakthrough technology. Suppose I'm establishing a new plant. So I don't have any historical data with me. So that kind of situation is known as unsupervised learning, when there is only input I am getting, some kind of signal image I am getting, but I don't know that what it is corresponding to. Okay, so that kind of condition is unsupervised learning. And third is the reinforced learning or semi-supervised learning method, in which correct output is received after you make a decision. That means for the learning, you don't have that input and output combination, but when you make a decision, or based on the input, you will be knowing the correct output. So you can compare your output predicted with the correct output, and you can modify your model accordingly. So these are the three basic learning methods. Today, we are going to talk about two machine learning algorithms: support vector machine, another is artificial neural network. So I will discuss them one by one and with the application as well. Till now, everyone is clear with this, or any question? Yes? Any question in this?
So we will take the question at the last.
Okay, you will be taking questions at the end. Fine.
Yes.
All right. So let me continue with this. So let us start with the support vector machine. Basically, we are having very good softwares available nowadays, like MATLAB we are having, Python we are having, and many other softwares which are able to use these algorithms effectively. You can directly use them. As such, there is no need of coding them. Okay, but we need to understand the mathematics behind them. We need to understand what is the logic behind them. Why? Because if you know that, then only you can optimize them. You can effectively use them. So that's why we are understanding them from the beginning. We will be understanding few things, then we will be able to implement in any of the software, then there will be no problem. So first of all, here you can see in the image, we are having image of orange as well as apple, and we want to classify them. So in this case, we are having two class problem. That means we are having one orange, another is apple. It may be positive or negative class. So two class will be there. Okay, one class and second class. So we want to classify them. You can understand it like this, that we are having a small kid in our house, maybe of age of 3 year or 2 year. We are giving them some toy of like those can be the sample of car. Okay, so we will be giving them 10 kind of different toy which are related to this some kind of car, maybe Tata, maybe Hyundai, maybe Maruti or Audi or Mercedes, whatever it is. Okay, so we will be giving them some model of car. So whenever they will be going out, when they will see a car, they will be able to recognize whether it is a car or whether it is some other vehicle. So we are having situation when we can classify into the two parts, whether it is there or whether it is not there. So in this particular example, we are trying to understand this support vector machine using the example of orange and apple. Here you can see on the left hand side I am having oranges, and on the right hand side we are having apples. Okay, suppose in this situation I am having axis, some kind of axis over here. Are you able to see this axis? Yes, I am drawing one axis. Are you able to see that?
Yes, sir.
Okay, so maybe like this may be x-axis, y-axis, some kind of. Suppose if based on the features I am placing them over here, some new fruit is coming. Oh, sorry, some fruit is coming here, or some fruit may be coming here. So based on this boundary, I can decide if it is going on the left hand side, I may say that okay, this is possibly orange. On the right hand side, if it is going, I will be saying that it is possibly apple. So basically that I am deciding based on what? This black line. Black line is the separation boundary, or it is giving me a decision function which is saying that whether this is going to be in orange class or this is going to be in the apple class, right? So this is important to identify. This black boundary I need to identify whether this is going to define the correct class to me or not. So this is going to be important. Now adjoining to this or parallel to this black line, there are two lines. One is this one, another is this one. So one dotted line, red line, is passing through the orange nearest class. Similarly, one dotted line is passing through the apple class. Okay, and in between these two lines, this is the decision boundary in between, right? So if we look at this, I am basically trying to identify a plane. For 2D, I can say it can be simplified as a line, but in the actual high dimensional space, it will be kind of plane. So to understand it, I am considering them as a line. Just to understand it, actually it is a plane, and which is going to classify them. So here you can see this particular line is passing through the nearest neighbor of this orange. Similarly, this is passing through the nearest neighbor of apple. So these points, this one, which are touching this boundary, these are known as support vectors. Similarly, this apple is going to be considered as a support vector, which is going to define these support vector hyperplane over here or support vector lines over here. In between these two, I am going to have a plane which is going to be my decision function or decision making plane, which is going to classify these two class. Okay, so with this background, I am going to this figure. I am having two situations now. On the left hand side, I am having circle. On the right hand side, I am having diamonds. Okay, now I want to basically classify them. I want to categorize these two. So you can see the two situations, A and B. In first situation, I am having hyperplane H1 and H2. H1 is passing through the diamond, and H2 is passing through the another circle. Okay, and in between there is a H, which is our hyperplane, which is separating these two classes. Similarly, now you can see in the next case B, the same problem is there, but orientation of these hyperplanes H1, H2 as well as H is changed. So you can see here, we are going to have a condition in which H1 is now passing through these two support vectors, where H2 is passing through these three support vectors, and in between there is a H. So if I look at the margin between the two classes, which is going to be defined by the distance between H1 and H2, you can see in first case margin is smaller, and in second case margin is very, very high, okay, in comparison to the first one. So which one is the better one? First one is better or the second one is better? Which decision boundary H is going to give me better result, first one or second one? So support vector machine, or if it says that the boundary which is going to give you maximum margin is going to be the best one. Why? Because if this margin is more, that means you will be able to clearly distinguish between these two classes. If margin is less, for example, if I consider like here another H, something like this, okay, so this H is basically classifying again these two. So but in this case you can see these support vectors are coming very nearby. So support vector may be coming like this, so one support vector is going through the circle class, another will be going something like this. Okay, so overall margin is less in this case, and you can see that in this case there is a chances of error will be more, because this is very close to this decision boundary. So if these support vector which are close to the boundary, then there is a chances of error will be more. So we want to avoid that situation. So from this, what is our gain? What is our understanding? Our understanding is that to classify two different classes, we can have any hyperplane H which can classify them into the two different categories, but the orientation and location of this H is very important. Okay, the H which is going to have orientation and location in such a way that the margin between the support vector hyperplanes is more, that is going to be the best one. Again, try to understand it from the example of line. Equation of line is given by y is equal to mx plus c, right? Now y is our dependent variable and x is our independent variable. M is what? Slope of this line. So slope is basically representing orientation. So this line is having different slope, the given line is having different slope, this line will be having different slope, and again, this another line is going to have different slope. So one thing is that slope M, okay, another thing is the intercept C. So this line can be over here, this line can be like this line can be this. So these probably this, all three lines are having different slope, but location is different. So when we are defining this value of H, we are having two important parameters. One is M, another is C. One is defining your orientation, slope, another is defining location, that is C. So my objective is to identify value of this M and C in such a way that margin should be maximized. Okay, so with the example of line we understood it, but if it is a hyperplane, it is a plane, there will be so many coefficients. So I may be having hyperplane H is given by W1 x1 plus W2 x3 x2 plus W3 x3 and so on, based on the number of dimensions. So x1 x2 x3 will be your input, and your H is going to be your output, which can be represented suppose by Y. So we will be having set of input and output that is going to define this H. To understand it, we are having a training set defined by xi yi, where x is going to be your independent variable, y is going to be dependent. So based on that, we are going to make a decision to classify different two classes. So yi output I am considered as positive class or negative class. So yi is equal to +1 for positive class and yi equal to -1 for the negative class. So output will be either positive +1 or negative -1. Okay, so these two classification problem I am considering here. Now, as I was saying that for hyperplane condition, my hyperplane WT x plus b. So here, rather than line mx plus c, I am considering a hyperplane WT x plus b equal to 0. So this is going to be the hyperplane which is going to give me maximum possible margin. So my objective is to identify values of w and b in such a way that the overall margin is going to be maximized. Now, if I consider output fx, this is 0 when we are between the two supporting hyperplane. So exactly if you look at our figure, we are having hyperplane between these two. So suppose this diamond is belonging to the +1 class and this circle is belonging to -1 class. So if value of this function is coming as positive, I will be saying that it is going to be diamond. If it is negative, I will be saying that it is going to be the circle, and decision boundary will be at fx equal to 0. So with this knowledge, I will be saying that for hyperplane h1 it is going to be +1, hyperplane h2 it is going to be -1, and in between there is a hyperplane which is our objective to be identified, that is our optimum hyperplane given by wx plus b. So this is going to be your hyperplane given by the black line. Okay, now if I calculate the Euclidean distance, which is going to define by -b by the mod of w. So this is going to be Euclidean distance of this hyperplane h2 from the origin. Similarly, I can identify the distance of the h1 as well, and difference is going to give me the required margin. So by doing some mathematics, I will be able to identify that margin is going to be defined by this particular parameter. So I will be coming back to this point. Now, for now, we can say that this function is going to belong to the positive class if yi is going to be, the function value is going to be positive. If it is going to be negative, it is going to belong to the negative class. So here you can see that if fxi is greater than equal to 1, we will be saying our output is positive class. If it is coming as less than equal to -1, we will be saying that our output is going to be negative class. Now, you multiply these two equations, yi with this one. Okay, now you try to multiply these two, yi with this fxi, and this one with the right hand side, left hand side with left hand side, and right hand side with the right hand side. If you do that, you are going to get equation yi fxi will be greater than equal to 1. If you do for the second equation as well, you will again, because of this minus sign will be changing, and you will be again getting yi fxi must be greater than equal to 1. Okay, so that is going to be the either of the class positive or negative. If I consider yi fxi, it will be always greater than equal to 1. So this is going to give me required constraint of this optimization problem, which is optimizing the margin. So equation 3 is going to be the required constraint. yi fxi must be greater than equal to 1. So this is going to be the constraint. So after doing this, I will be calculating the margin, and geometric margin will be given by this equation gamma I over mod of w, which is going to give me the distance. So the final Using the theorem, I will be getting the final equation 5 and 6, which will be our non-linear optimization problem, which is giving basically a quadratic equation, minimize half of W square. This is going to give you the overall margin as a maximum one, and subjected to yi WTX plus B is greater than equal to 1. This equation is solved by the different techniques, common optimization technique, like using Lagrangian multiplier method and using Kuhn-Tucker condition. So you can use them to get the value of W and B, and after getting the W and B, that is going to give you maximum margin, and corresponding hyperplane is going to be your decision function. So this is about like support vector machine, how it is working, mathematics behind it. But if you do it on MATLAB or Python, you are having ready-made things being done already in the subroutine. Some functions are already there, you can use directly, and you will be able to classify them easily. Now, next case of the support vector machine is the non-separable case. We are having another possible condition in which we want to classify situation like this, in which some apples are going over here and some oranges are going over here on the right hand side. Now, how to develop a hyperplane or how to use support vector machine to this kind of problem? So in this kind of situation, you are having two options available. One option is you can have a boundary which is non-linear boundary. Okay, means I am saying that you can have a condition in which you will be able to take non-linear kind of line, okay, something which is going to exclude these apples. Sorry, this will be going like this. Sorry. So in that way, you will be getting a non-linear line which is going to separate this one. Second option is that since it is not possible, we need to relax our constraint. So first option, when we were having the non-linear kind of line, so basically we need to include non-linearity in our system. So that can be done by using kernel function. To understand it in a very simple way, that what is kernel function? Suppose I am having a function y equal to x cube, which is a non-linear function. So if I consider x cube equal to z, so I will be having equation y equal to z, which is again a linear relation. So basically x cube is mapped into the z, okay, or x cube I can consider by some equation x cube is equal to z plus c. So in that case, basically non-linear equation being converted into the linear equation. So that part is done by using kernel function in AI technique. So we can use some kind of kernel function which is going to convert these data into the high dimensional space, where they will be able to separate it by a linear hyperplane. So that is one way. Second way possible is that since if I want to use a linear plane only like this, then definitely this green is going to come here. So the constraint which I have defined here, if you remember, this one, fxi will be greater than equal to 1 if yi is equal to 1. But in that case, this is going to be violated, that this constraint is not going to be satisfied. Similarly, since apple are going in the orange or orange is also going into the apple, second constraint is also going to be violated. So how to handle this condition? That means my constraint is not going to satisfy in any of the case. So what I can do, this was my constraint equation 3. So I will be adding some variable, extra variable over here with the 1. So that is known as slack variable. If you remember in optimization, there is a slack variable and surplus variable we are using in big M and two-phase methods. So the same optimization way we can do here also. I am introducing in the constraint a slack variable over here, which is going to relax my constraint, so that this constraint is now relaxed and I can solve this optimization problem. But since this is the slack variable introduced from my side and it is basically giving negative thing in classification problem, I should have my algorithm in such a way that it has to minimize the value of this slack variable and try to make it 0, because this slack variable is having value greater than equal to 0. So minimum possible value is 0. So I should try to get the value of the slack variable as 0 for better classification without violating any constraint. So for that, I am using my constraint or my objective function 15 given over here. So this constraint is given here, and you can see here I added this C I equal to 1 to m gamma I. So basically I equal to 1 to m is saying that how many constraints we are having. Gamma I are representing slack variable introduced in each constraint, and C is defining a large penalty. We are imposing this penalty because we want to minimize this value of gamma I. So it is plus with penalty. So objective function will try to minimize this value of gamma I, so that this will be avoided in the final solution. So this is the another way to consider this kind of situation when we cannot linearly classify our objective function, or we cannot linearly classify two classes. Is it okay? So with this background, we can use support vector machine for various applications. So in question answer session, I will be also asking one question related to this support vector machine, and after clearing your doubt that how we can do something with this background. Next, based on this, our now new optimization problem will become half W square plus C summation of all these slack variables from I equal to 1 to m subjected to the constraints given by equation 17. So this is going to be my optimization problem for this kind of situation. All right. Now comes our Lagrangian multiplier method. You can use them to classify them, so I'm not going in that detail. Next comes artificial neural network. Artificial neural network, I think most of you might have already used, very commonly used technique nowadays, and it was developed long back. So somehow most of us have used it. So I'm going to just show that how it is working. Basically in this case, like brain, we are having certain neurons. So neurons are classified into the three part: input, hidden neuron, and output neuron. Input neurons are basically taking all input variables. Output is basically giving net output. So you may be having one single output. That means you can have that, okay, this is the water, this is not a water. So based on that, you can have a single output or multiple output. And in between there are hidden neurons. Basically, these are the neurons which are processing it. So whatever input we are getting, that is being sent to all hidden neurons, you can see here, and that is basically processed through these neurons and giving the output. So ANN is an adaptive system that changes its structure according to the information flow through these networks. So here again, if I see a particular neuron here, you can see that we are having set of input x1, x2, x3. We are giving weightage to each input w1, w2, w3, wj. So x1, w1, x2, w2, x3, w3. So this is going to be input. Then we are adding some function. So that is b, bias. So x1 w1 plus b1, then x2 w2 plus b, and likewise. So that is going to give coming in the summing function, which is going into the activation function. So activation function is similar to the kernel function which we talked about in the support vector machine, which is going to introduce nonlinearity in the system. And after considering that particular part, we are going to get the required output. So this is the basic structure of artificial neural network. We are having different kind of neural network like single layer feed forward network, multi-layer feed forward network, or recurrent network. So activation functions are used for the nonlinearity. We are having hard limiter, threshold logic, linear, sigmoid. All these are the different kind of functions which are introducing nonlinearity in our system. So with this background, let me go to the application of ANN and support vector machine in the different domains. So like we are talking about the industry 4.0, we are talking about various activities with the help of our different sensors, actuators. We will be doing many tasks with the certain decision making. We are going to also talk about today some of the tasks which we can use, machine learning techniques can be used for those tasks. So first is in the maintenance. So when we talk about the maintenance strategy, we are having three kind of main maintenance strategy. First is breakdown maintenance, second is preventive maintenance, and third one is the predictive maintenance. So let us understand them one by one. First of all, what do you mean by breakdown maintenance? Which we commonly see that, okay, in our house, bulb is fused, tube light is fused, then we are going to replace it. So basically we are replacing whenever things are not working. It is stopped working. Second is the preventive maintenance. When we want to go with this certain kind of preventive strategy, we want to avoid those kind of failures. So we are continuously saying that our system should be having certain kind of maintenance activity. For example, in our house, we are having vehicles, automobiles. We are going for servicing of those vehicles regularly. Sometime when we go, we are having some problem in our vehicle, then that is the situation when we talk about the breakdown maintenance. Suppose I am having puncture, then I am going to the shop, I am getting it done. So it is a breakdown maintenance. But when we are going for a regular scheduled maintenance kind of thing, I am going for the servicing, then it is known as preventive maintenance. So when I am purchasing my vehicle, I am going for the maintenance activity which is going to be performed based on a particular time duration. So that kind of activity is considered as a preventive maintenance. So before going to the predictive maintenance, let us understand that what is the advantage of the breakdown maintenance and what is the disadvantage, and similarly what is the advantage of preventive maintenance and what is the disadvantage. So breakdown maintenance, when we talked about, breakdown maintenance is related with the maintenance activity when things are used up to their best possible life. So advantage with the breakdown maintenance is that we are best way utilizing its whole life. So whole life of the component is being used. Okay, so that is the advantage. But disadvantage is that we are going to have a failure, complete failure, and in that situation we need to immediately rectify that mistake, and that will be requiring lot of efforts you will be needing. Okay, so that kind of situation is to be avoided. So that's why we are going for the preventive maintenance. So preventive maintenance, as I was talking, that it is a scheduled maintenance like we do for the automobiles. So in automobiles, we are going for the regular maintenance task to the vendor. So in that case, advantage that we will be having less chance of failure in between. Second, that overall maintenance will be requiring less money in terms of downtime. Okay, else in case of breakdown there will be a lot of downtime, so that will be requiring extra cost. But in case of preventive, less downtime will be there, so you will be saving that cost. But disadvantage is that sometime when you are going for the vehicle maintenance, you were asked by the maintenance engineer that, okay, I need to change the oil, gasket and other things. So you will be worrying, okay, I have not utilized it properly, even I have run for only 500 kilometers, engine oil, what is the need of changing that? So that is going to give you extra cost, and that extra cost is bothering you. So that kind of situation is coming in the preventive maintenance. So extra cost is involved because of compulsory change of some of the component. So that need to be avoided. And third category is the predictive maintenance. In predictive maintenance, you are trying to overcome both the aspect, that is downtime as well as the extra cost due to the regular maintenance, even if it is not required. So in predictive maintenance is nothing but the condition based maintenance, where we are continuously monitoring the condition of the person and also condition of the person or the machine. Okay, like human beings, when we are continuously monitoring our blood sugar level, we will be able to predict that, okay, what is happening. We can do the accordingly medication or our exercise, everything we can plan accordingly. Similarly with the machine also, we can continuously monitor their condition and we can take a corrective action based on their condition. So that kind of situation is the predictive maintenance, when condition is monitored throughout the life, and whenever there is a problem we are going to rectify it, right? So it is going to give me less breakdown, less downtime, as well as component will be only changed when there is a signal that, okay, life is about to be over. So that is going to be advantage of the predictive maintenance. So vibration analysis is the common technique which we use for the machine condition monitoring or the condition based maintenance. In this, we are continuously monitoring these vibration signature. Why it is important? Because vibration based condition monitoring is having two advantages, that every failure mode is having their own different frequency, and that frequency is going to change if that component is having any kind of failure. So that is able to tell us that what component particularly is having a problem. Second is the amplitude of each different vibration component will remain constant unless there is a change. Okay, so sometime amplitude will be telling you, yes, vibration is more, there is maybe looseness in the system, misalignment in the systems. We are going with our vehicle and we say that it is going off-road. So we will be saying there is an alignment problem in our vehicle, we need to go to the shop and get it done. So that kind of situation we can detect from the vibration analysis. So today, machine learning application, we are going to talk about that how we can use them for the bearing fault diagnosis. Okay. So when we are having a machine, so we were having this kind of machine in which we are having shaft. Shaft you can see over here in between two bearing support. We are having two bearing support, left hand and right hand side, and you can see there are 1, 2, 3 and 4 sensors over here to get the data about the vibration. These sensors are basically vibration sensor getting vibration in horizontal and vertical direction. Here you can see another sensors over here and another over here which is taking the speed. So we are continuously monitoring the speed using this tachometer signal. We are getting the vibration over here also. So we are having certain vibration channel which are giving us vibration in the system. Now if I look at that, what actually I want to know, you can see this methodology. I am having machine with the sensors placed on it. We are acquiring data which are basically vibration data in this particular case. But for you can take the motor current signature, you can take the acoustic, you can take the noise. Like in conventional, there are noise application, like even in our two-wheeler, based on the noise, we can say there is a problem in our vehicle. Now we are going to extract certain feature. This is very important. What do you mean by the feature? Feature is nothing but characteristic. Like human beings, we are saying that the color is whitish, color is very whitish, or we can say black in the color, eyebrows are like this, nose is like this. So basically we are defining characteristic of a face. So same way, we can say that whenever we are getting certain signal, that will be having certain kind of feature. So we need to extract those feature. We need to use those feature to identify fault. So as we are talking about the machine learning algorithm, we need to train them. So we are having certain set of input and output. We are classifying our data into the two part, training data set and testing data set. Training data set, we will be having certain feature. We are using ANN and support vector machine. After getting the trained model, we are going to use our test data in this trained model and going to predict that what kind of fault is there in our machine. So this is overall flow chart. In my case, I have considered 5 different cases. Here, fault cases are 4. Outer race fault, inner race fault, bolt with corrosion pitting, or the combination of all these faults in a bearing. So we are having 4 bearing defects in the consideration, and 5th one is the healthy bearing. Remember that whenever we talk about the fault diagnosis or medical diagnosis, we should have a healthy data which is going to be considered as the baseline data, and the variation from this baseline data is going to tell about the condition of the machine. So we are having different kind of faults, like given over here, we are having outer race crack, we are having corrosion pitting ball. So overall flow is like this. We are having healthy and faulty bearing conditions. So we are having 5 conditions. We are using machine fault simulator to generate vibration signal. These vibration signals are giving me different features. So in this particular case, I am using statistical features. Statistical features means like average value of that vibration signal, RMS value of that vibration signal, skewness, which is representation that about mean how it is shifted, overall data. So skewness or kurtosis value, that is going to be representation of peakedness in the system. So those kind of statistical features I am calculating from raw vibration signal, and these features with the corresponding output are being fed in the machine learning algorithm for the classification purpose. So I will be able to find out what kind of fault will be there. So this is going to be the overall methodology. Now, as a researcher, we need to understand that where is the research component. So every step shown over here is having some kind of research component. First of all, healthy and faulty bearing. So you can consider different faults for the bearing. So like I have considered like crack, you can consider pitting. I have considered pitting, you can consider corrosion. You can consider wear and tear. You can consider waviness. So you can consider different faults. Apart from that, you can consider the severity of faults. That, okay, 2 mm fault, 3 mm fault, 5 mm fault, or 2 micron fault, or 5 micron fault. So severity of fault can be considered. Then, after getting this, you need to also check that how many sensor or which particular sensor can be used, whether it is acoustic, vibration, or current signature, which kind of signature you are going to use on the machine to capture this data. So that is going to be another research problem, that which particular signal processing, signal method is going to be best for you. Then after getting that raw vibration signal, you need to process the signal. Raw vibration signal, as you can see in the figure also, it is very difficult to give interpretation from this. I cannot even find out directly that what can be the possible frequencies or another thing. So I need to process the signal. Also, these raw vibration signal may be having some component from the other machine component, which is not part of my study or the not in the scope of my this particular study. So in that case, I need to remove those kind of noises from the signal. So I need to process this raw vibration signal. So signal processing is another research domain you can use. After getting this signal processed through the different techniques, you can calculate these features. So I have used some feature, you can develop or you can use other features as well. So using different features, that is going to be another domain. Using feature ranking technique, that means which feature is going to give you best output, that is going to be another research domain. After getting these features, I am going to take them as an input to the machine learning algorithm. So development of these machine learning algorithm is going to be another research area, which is normally done by the faculties or the students from the computer science background. So they will be dealing with this particular aspect, that what can be the new techniques which will be able to classify them in a better way. So this is going to be another research domain. Then comes fault diagnosis, that what kind of faults are there, we can identify them. So all these components I have already discussed, that okay, how we can do research in this whole domain. So every component is having different. So next, the research I am going to talk about will be based on the signal processing, that will be discussed later. But let us see that what was the outcome of this research. In this research, I use these kind of statistical features. I have used 73 instances and the outcome was like this. The support vector machine was giving efficiency of 74% around, and ANN was giving around 71.23% efficiency. This work was published in year 2011 in the journal Expert System with Application, which is having impact factor of around 4.5 or so. So at the time it was published, and after that I thought that the efficiency or the classification what I am getting, I need to improve this. So as I was saying that we are having different research domains. So in next work what I did, I'm skipping some of the slides because of time challenge. Let me come to the next one. Yeah, so here you can see that I was using the same methodology here also, but you can see that I am processing my raw vibration signal through the wavelet. So I use the time frequency analysis known as wavelet analysis on the raw vibration signal, and the signal which I am getting after wavelet, that I have used for the feature extraction. So I am getting feature from this wavelet analysis, and those features are being fed into the machine learning algorithm. So this was the research part over here, that is wavelet analysis. Okay, so I was using continuous wavelet transform for this particular task. So let me show you that what I did in this. There was a raw vibration signal, as I told you. Raw vibration signal, I have considered 30 samples for the ball fault, inner race fault, combined component defect, healthy bearing, and outer race defect. So total 150 sample you can see here. These samples I have used with the wavelet. Now wavelet is the time frequency analysis. So I considered that, okay, which wavelet I should use, because at that time when I used this particular technique, at that time there were around 324 mother wavelet. So wavelet basically is a kind of a special wave which is going to be considering different signals. So the wavelet which is very close to your signal, very similar to your signal, is going to be the best wavelet for your application. So I may be using in my bearing signal, you may be using in gear signal, you may be using it in the our brain signal, EEG. Propose this wavelet selection methodology which is going to give me best possible results. So I tested this methodology on 3 real valued wavelet and 3 complex valued wavelet. I applied them here and calculated energy of the wavelet coefficient and entropy of the wavelet coefficient. I calculated this ratio of total energy to total Shannon entropy, and the signal which is giving me the maximum value of this energy to entropy ratio, I have used that particular wavelet as a best wavelet for my particular application. So here you can see that I have used 128 scale. Here I am having energy to entropy ratio, and you can see that this particular scale is giving me maximum value of this energy to entropy. Similarly over here, these 2-3 signal we are having a value of around 80 scale number. For this green one I am having value of around 30. So you can use a particular scale which is going to give you maximum value of this energy to entropy ratio for your wavelet or scale selection. So this was done in this paper, and this was published in the Journal of Applied Soft Computing, again published by the Elsevier Science, and having impact factor of around 4.6. And in this case I was able to get efficiency of around 98.667%. So this was the efficiency I could achieve from using this wavelet based analysis. Okay, so these are the 2 applications I have considered for the bearing fault diagnosis. Okay, now let us talk about how I can use it for any other application. So remember that these particular cases which I have considered here, that is basically a classification problem. I am classifying them. Okay, you can also use them for the regression problem. For example, you want to have a certain set of parameter in your manufacturing operation, and you want to predict what can be the possible surface finish for that. So you can train your algorithm based on the certain input parameter, process parameter, and there is a set of output which is maybe your surface roughness value, which may be your hardness value, which may be your any other mechanical property. Okay, so you can relate these set of input process parameter with the required output, and that correlation can be used for the further prediction or deciding the optimum process parameter. So that kind of thing you can do using these machine learning algorithm. Now let me go to the another case study. This is not done by me. This is the study of some author I will be showing in references. And in this particular study, this appealed me because this is again a new application in the case of product design. Here idea was, let me define problem first. So idea was, person wanted to know that what kind of possible fragrances which of the perfume. Okay, so we are having various perfume deodorants available. So they want to correlate that what can be the shape of the possible bottle which may be related to the kind of fragrance. Okay, so fragrance values, they have defined certain value. This is the soothing fragrance, this may be a mild fragrance or something like that. So that they have defined those values, and they tried to correlate the shape of the bottle with these fragrances. So they identify initially 500 various world famous fragrances. Out of removing that, okay, some of the similarity between them, in a first instance they've identified 200 fragrances. After preliminary assessment, discarded the remaining. Then they hired 12 design experts, and they used this Kawakita Zero method for again refining these fragrances. So after doing that refinement using this particular method, they identified 28 fragrances which are considered for this particular study. So these are different fragrances in which they identify product form elements. So they identify bottle shapes. So if I look at this, you can see there are 28 different kind of perfume bottles. Okay, so these perfume bottles, they have correlated with the kind of fragrances. So they define form element, that means what kind of neck is there, what kind of bottle cap is there, what kind of bottle shoulder is there, what kind of bottom is there. So they define these kind of features in perfume bottle, and they correlated them with the some kind of output which is the kind of fragrance. So you can see here that they have defined these design form element, shape of the bottle, connection of bottle top, shape of bottle shoulder, and so on. If I enlarge it, you can see here on the left hand side, and type of bottle you can see here, type 1, type 2, type 3, type 4, and so on. So that kind of features they have defined and used those features in this kind of table. So you can see that training sample vector, they form that x1, x2, x3, x4, these are up to x9. So these are basically features they have defined. So they define these form elements on the left hand side, shape of the bottle, etc. So these were the 9 features, total 9 feature, texture of bottle, transparency, and so on. So 9 features they have defined, so x1 to x9. So these are the features. And fragrances they categorize into the 3 parts: soft, classical, and fashionable. So they have given them some points. So 3.22, 2.74, 3.62, these are the different points they have given. And now they are trying to identify based on the feature what will be the possible value, so they can classify into the soft, classical, or fashionable fragrance. So this is a kind of numerical value prediction, and that's why it is considered as a regression problem where we are predicting certain numerical value. So using that, they identify different consumer behaviors. So consumer have considered soft, classical, and fashionable perfumes. They use these samples, they've identified these values. Now they have used neural network here, and they identify comparison of these fragrances with this neural network output. And you can see here in the third case you are getting a very less error, that is root mean square error is coming as 0.0961 only, which is a very good result. So this kind of application is also possible using the ANN models or the support vector machine model. So with this background, you can use different software packages and you can identify whether it is a regression problem or whether it is a classification problem. So that part you can do. So this is all from my side today, and you can ask your queries, then I will be asking few questions from you as well. Okay, so these are the references, and this perfume bottle example is example 7. You can see here, which is Lin and Chen, artificial intelligence models for new product design and application study. So this is the reference. The 2 examples of bearing I have taken from reference 5 and 6, expert system with application and applied soft computing. These are the 2 references I have used for this particular part. Okay. So now I request to ask any query if you have.
Yes, sir. I think we have some queries in the chat box, so I can read for you, sir.
Yeah.
Sir, Akash Zain is asking, sir, can you share the file of Python in which we can see SVM and SANN?
No, Python files are readily available. It is Python is open thing, so you can search it and you can get it. No issue in that.
Okay, and Mr. Satish Kumar is asking where to get the mechanical engineering related data sets other than Kaggle site for practicing machine learning algorithm knowledge.
Mechanical, again, there are various sites. For example, we are having Case Western University Reserve data set, bearing data set is available over there. So you can use that as well. Then there is a prognostics and health management, PHM data set is also available, in which they have done some of the studies related to mechanical as well. So on the gear, bearing, wind turbine, so there is some data set available on PHM also. So you can use those data set.
Okay. I think no more queries, or I think we check those.
No more queries?
I think so, sir.
Okay, good. So let me ask you one question. We have discussed. Okay, yes. Now I got one question from Vikram Sharma. Can you see that question?
Yes, sir. Sir, can we make more than 2 group in SBM, like
Yeah.
in making cell of cellular manufacturing system?
Yes, yes, yes. Actually, this was the question I wanted to ask, and I was referring to that. Okay, how you can use support vector machine for the multiple group classification? I am having more than one group. Then how you can use them for this particular task? Okay, so what is the way? So first of all, I request you to just think that how we can do that. Just give a thought, then I will be definitely telling you that what can be the possible ways.
If any participant wants to answer, then please unmute your mic and then you can answer.
By using the genetic algorithm,
By using genetic algorithm, how?
in which there are the multiple layers, we can use the multiple.
No, we need to classify using support vector machine. The question is being asked because we have discussed that how it is algorithm is developed. So developed, we talked about that positive class and negative class. So we talked about 2 classes only. So obvious question is that if we are having multiple classes, like in my case, I have used 5 class problem in which heavy bearing, then inner race fault, outer race fault, and many like ball fault and the combined component. 5 faults I have considered. So the obvious question is coming that, sir, how we can extend it for the 5 class problem? So answer is that what you can do, for example, you can consider outer race fault and compare it with the all other fault. Okay, so all other classes, case 1 is considered as a positive and remaining other cases can be considered as a negative class. Okay, positive versus negative. Okay, so now using that I can identify that yes, these particular data set or these input is corresponding to outer race fault. I can flag them. Okay, this is outer race. Now again I will select, because remember that support vector machine is the supervised method, so input and output both are known to me initially for training purpose. Now what I will do, I will consider now inner race fault and remaining other as a other category, that is negative class. Okay, again I will be identifying that okay, this is going to be the inner race fault. In that way, one against all, I will be using that algorithm, one against all, to identify each and individual class, and in that way I can use support vector machine. Okay, all right.
Okay, sir.
Okay, one more request from my side. All of you may be wondering, whenever you will be using these machine learning algorithms, sir, like you gave us a solution that wavelet should be used by some wavelet selection criteria. There is wavelet for a particular problem. So machine learning also, is there any way through which I can know that, okay, this machine algorithm should be used for this particular study? As such, we don't have that particular kind of scenario that any particular algorithm is good for every case. No, it is not possible. Okay, what we can do for our study, we can conduct different AI techniques and we can make a comparison between them to get it done and even get it published. One more thing I would like to say here, when I did this particular study, I read a paper which is a very, very good paper. I request you all to note down that support vector machine under test. Support vector machine under test. This paper is very good, specifically for beginners who want to understand that what it is. Okay, this study is again important because various machine learning algorithms are compared in this study. Okay, and after comparison, Mayer has done this particular study, and after comparison he said that which one is going to be the good. So at that time he concluded that support vector machine is very good techniques for the classification problem While for regression, ANN and support vector machine both can be used. So they conducted various different AI techniques. So they used 16 classification methods and 9 regression methods and compared them with each other, considering different classification problems. They have not considered a single case. They have considered many problems, and after that they have concluded that support vector machine is good for the classification. So I have given you a link in chat box. You can refer this particular link. This is going to be that paper. I request you all to read this paper. This is very good, and this can be like a base paper you can consider for your machine learning application. Similar kind of study you can conduct for using different deep learning algorithm, extreme learning algorithm. You can compare those algorithms for your problem, and you can make a good paper out of this. Okay. So this is all from my side. Any other queries?
So we can wait for 1 minute if we are there any query then. Otherwise we will close the session.
Yes.
Any query from our participants? Right? No sir, I think no more query now. So thank you sir for accepting.
Hello, sir.
Yeah. Somebody asking something?
Yes, sir. Sir, can you share the file of the Python in which you perform SVM and ANN already? As I am new to the Python, so it
No,
will be very
actually,
helpful for me.
I did programming in MATLAB at that time. Okay, so Python is not used by me, and my students are working at present on the Python. So let me ask them to share some of the tutorial in which you can implement these AI techniques on the Python. Okay, that's what you want?
Yes, sir. Yes, sir.
So I will be getting link for you, and I will be sharing with the organizers so that they will be helping you.
Okay. Thank you,
Okay,
sir.
sir.
Yeah.
Okay, sir. Okay, sir. So thank you very much, sir, for this enlightening presentation on machine learning. I think all the fundamentals of machine learning have been covered by you, sir, so nicely. And I hope the participants will use the knowledge of the machine learning in future in their research work. So, sir, on the behalf of organizing team, I am really thankful to you, sir, for sparing some of your valuable time with us. Thank you, sir.
So I'm also very thankful for your team, Dr. Naren, Dr. Mishra, and other organizing team. I don't know each and every one, but my personal thank to everyone. And it was a really good session. I hope that we all will be getting benefit from these kind of sessions from each other.
Yes.
So thank you, everyone.
Thank you, sir. Thank you. Okay, so dear participants, now it's lunch time. So we will be meeting again at 2:30 p.m. So Dr. Krishna Kumar Jain from DAY-4 in Jabalpur. So he will be delivering a talk on the product development life cycle management. Thank you. So see you at 2:30 p.m. Thank you.
सर से फोन किया मैंने सर वो आप मैंने सर से फोन किया था Good afternoon to all of Professor Jain. You are with us. एक पता क्या क्या करें Good afternoon to all. Professor Jain is with us. There are some connecting issues, so as soon as they will get rectified, we will start the session. Just wait for 2 or 3 minutes, we will able to join him. Okay, sir, 2 minutes. Fine, sir. Okay, sure, sir. So, dear participant, please be with us. In few moment, we are going to start the session. Okay, fine. Okay, Jan sir, shall we start?
Can you hear me now?
Yes, sir. Hello.
Yes, sir, we can hear you, but sir, your voice is not louder. Let me check it further again. Oh, I am audible? Yes, sir, yes,
Yeah,
now
yeah.
you're audible. Actually, I was in office, so I was trying to connect with desktop. But anyway, I have switched over to laptop, so I hope my voice is clear.
Yes, sir. Now your voice is very clear. So Professor Jain is already being with us yesterday. So today he is going to give us the session on the product development aspects. Jain sir, you can start, sir.
Okay, and in the before start also, if there is any queries anybody is having related to previous talk, we are also welcome.
So, dear participant, if you have any query, you can directly ask the Professor Jain by unmuting your mic, or rather, you can type it on chat box.
Yeah, before I share, I can read the chat box and answer the queries. And if no related queries regarding CNC machining, part programming, etc., we will talk on product cycle and product life cycle. So I would like to hear from the participants. Let me see how many are really connected with us, or I'm just looking at the number at the moment, 188. What is our perception about the product life cycle? Let's have this session little bit more interactive, or rather a one-way going.
Participants, you can interact also, yeah.
Okay, let me ask the question. Let's see. What is the difference in product cycle and product life cycle?
I think, sir, some of the answers are in our in the chat box. So I think.
Yeah, I'm until I start sharing now, I can read the chat box. So I'm reading in the chat box also. Because we also need to find the ways how we can make such sessions at least some context, some kind of interaction. Otherwise, we may lose our interest in such programs. Lot of things are Swayam, Coursera, NPTEL are already available. So my open question to everybody, what we have the difference between the product cycle and product life cycle?
Sir, whatever I know is in product life cycle we have growth phase, maturity phase, decline phase.
Okay. Okay, good. We have the maturity, growth. Okay, perfectly fine. Decline, and finally the end of the product life. What about the product cycle?
The steps for manufacturing a product. The steps for manufacturing a product is considered as a product cycle.
Okay, steps for manufacturing a product, right? Right, very nice. That is what is our today's topic. We have to discuss on product cycle and product life cycle. And we can see in how these things would be helpful in our this.
Good afternoon, sir. Product cycle is the where designing, manufacturing, and marketing unit of the product.
Hello, good afternoon, sir.
Yes.
Sir, product cycle is simply start from the detection of need to product, while product life cycle also adds sales after services.
Okay. Okay, let us begin with the product cycle, and we will have some more queries in between the session, right? So, in today's session, the product life cycle management is the topic, and we will begin with product cycle first. So we understand how we design and develop the product, and then how the different stages of product development move ahead with the improvement in the product design and the manufacturing, shipping, marketing, etc. Right? So let us see how the product cycle begins. How we basically design a project, right? So first thing, I think my slide is visible to you or not?
No, sir. No, sir.
Okay. Okay. Let me. Is it now my slide is visible?
Yes, sir. Yes, it's now visible.
Okay, thank you, Dr. Naresh. Thank you, Dr. Aviral. So, we begin with the product cycle, right? How the product cycle starts. We begin with the design need, right? What is the design need we have? Means what the service or the product is required. That we first identify, then we look for the particular product or particular services for the as per our requirement, right? So we begin with the design need. The second thing, we want that design definitions, specifications, and requirements, right? So when we say design need, what we begin? Suppose I say a question that I am sitting in my office or wherever you are sitting in that room to be cool. Then we talk the design definition and design specification means more details. Our design need may be that the temperature to be maintained at certain degree centigrade, or if it's a hot season, we want to maintain the temperature, say 20-25 degrees centigrade. So that may be the design need. But when we talk about the design definitions, specifications, and requirements, then we have to see what is our specifications. So, but when we comes to definition, specification, and very specific requirement of the design, then required AC are required. And if we talk about, say, for example, AC required, what should be the AC capacity? Then we look for many other things like how many exhaust gates in that room or in that office, how many times door is open, closed, how many people are sitting there, is there any heat source in that room, or is there any heat sink in the room available? So all these things we consider, but our design need starts with that, right? So with this we will finalize the design specifications, design applications, right? And then we generate our own requirement. Now the next thing is that for any product, before designing or even identifying what product we are going to design, is that collecting relevant design information and feasibility study. Say for example, what has happened before this product comes, what is the current solutions available for this problem, are people using coolers, are people using AC, or only fans are sufficient. Now in this situation, say for one attribute, you can say the location, where you are. Are you in Delhi, where the humid environment? Are you in Shimla, right? Are you in Gwalior? Are you in Jabalpur? Are you in Jalandhar? So the location will play important role. The weather conditions will play a role. And our design need is remain same, remember. What we want, the temperature of the room should be controlled or within the human comfort zone, right? Now, then what is the environment temperature is available, right? And what is the season is that, what is the ambient temperature available? You might be somewhere in Russia and the you don't require even AC, you require a heater because your temperature you have to maintain in 2025, right? So you have to look what the outside temperature is available. So we will collect so many relevant informations and feasibility study. We have to those are available to install a AC or not, or maybe the window AC or split AC or central AC. What kind of our requirement is this, right? So these things start with design need, then specifications, definitions, and we collect the relevant design information, right? Right? Which type of product is there? So we begin with a small sketches, etc. Then collecting load calculations, etc. Right? So these things will come under the design conceptualization phase, right? Then we go for the design modeling and simulation, right? Then you apply a lot of things for simulation. What is the room temperature? What is the outside temperature? After 1 hour, what would be the temperature? Or how many people are sitting inside? Or what some machine is installed inside? How much heat generation will take place? So all these things we consider, and then we model the design and simulate it. This whole process we call the synthesis, right? So we divide in the design process in two, synthesis and analysis, right? So this is all synthesis. We do a lot of brainstormings, etc., right? And a lot of survey to be done, meeting with different people's customers, what the product may be the feasible, right? Whether the people have that kind of buying capacity to purchase this product or not, or something else maybe in that area, right? Then we go for the design analysis. Whatever the product we will have, we need to analyze it. Then we complete the final design specifications. Means a different assembly, different products, different components of that particular product, how to be made, what are their dimensions, right? And what would be the process? Are you going for injection molding or 3D printing or anything else? Different kind of process tolerances, etc. we need to finalize, right? Once we finalize the design of our product, then we talk about the evaluation. So here we have to apply our engineering knowledge, engineering theories of failure. So in what situation design would be perfect, or in what situation or circumstances your design may be fail. So that is the design evaluation. Once we are satisfied with all this, design analysis, design specification, and design evaluations, then we do the final communication or documentation. Means with all tolerances, machining process, and everything we will document it. On which machine, you can say the complete route planning, process planning, we will do in the next page. But here, all our manufacturing drawings would be ready. So for example, something you have modeled in geometric SolidWorks or CATIA, then you are going to generate 2D drawings, right? 2D drawings of that product so that they can be supplied to the shop floor. Right? These 4 blocks we call the analysis, right? So for design process, we have synthesis and analysis, 2 parts. Now, see, once our design process is completely ready, right, and documented, we have the process plan, right? What are the processes to be followed, what the processes has to be taken care, right? Lathe machine, milling machine, or different machining sequences to be identified, right? If we talk about the detail, then we have to do the production planning, design and procurement of new tools, We may also need to order some material, then NCCNC, DNC programming to be started, right? So process planning, production planning, and all these things, manufacturing activity. Then we come to the final production, right? With this final production, go with the quality control, and with quality control, finally, we go for the packaging. So here a lot of things need to be done while your product in a stage. You can parallelly start with the requirement of the packaging, etc. I will talk on some other slide for the concurrent engineering and the requirement of packaging and why we need to do these things simultaneously, right? Then after packaging, we need to ship the product, right? Then finally, marketing. So you see, you start with the design need, design specification, collecting the relevant information for that particular problem solution, right? Then with the problem solution, we come out that, okay, this product may be useful, right? Then we have a design modeling and simulation, right? So it may be a clay modeling or something like that at this stage. Then we go for the design analysis. Then after design analysis, the design specification will work on, right? Then evaluation in our abstract engineering knowledge. Then finally the communication, right? So this is all the CAD portion, right? But when we do all production, quality check, packing, shipping, and even our product reaches to the market, this product cycle is not complete. This is a recursive process. From this market, we also need to collect the feedback. So this marketing block will be collected back to the design need. Sometimes it may happen also that we launch one product in the market, and what is happening, a new that product itself may create the requirement of another product, right? So suppose you launch a new car in the market, so a lot of inventory accessories, and that may also generate some requirement of new products, right? Like car cover, steering cover, glass covers, the wheel covers, or many other things will come into picture, right? So this is the product cycle. We call how the product is design, conceptualize, and after the conceptualize, it has manufacturing in various steps, then shipping, marketing, and then we collect the feedback, right? At this stage, somebody would like to add to it, or else look at that first portion. This is the complete design. So within the design, we have two sub steps: synthesis and analysis, right? And in this portion, within this, we call the CAD process. Can you see the colored box differently? The CAD process, right? Computer aided design, right? So this is the computer aided design process. Then you look at that. On the bottom side, we have the manufacturing process, right? And we have this up to packaging, the computer aided manufacturing process. So this is the typical product cycle we use to design and develop a new product to the market. Anybody would like to add any example to that, the product cycle? I see many of you have already studied that. And if not, then we will see how in industrial environment we used to implement it. What kind of packages we use to implement this. Look at this typical utilization in the industrial environment. Look at that. We have the geometric modeling of conceptual design. First thing, for implementation of this product cycle, what is required is geometric model of conceptual design. Okay. Then, is design evaluation possible with available standard software? Anybody would like to answer what the geometric modeling package we require here for conceptualization of design, and then whether the evaluation is possible or not? So we need to check if the design evaluation is possible with available software or not. If yes, then we will do the design testing and evaluation, right? If not, then we need to develop our own customized packages, subroutines, subprograms for testing of our design, whatever we have designed, right? Right, and then we will come back to the design testing and evaluation, right? So further we move, check that if the design is final or not, it is acceptable or not, right? If it is not, then we will go back to the geometric modeling, right? Quite possible, whatever the model you have designed, it shows that it is weak in certain portions, right? Maybe after FEM analysis or anything else. Then if it is yes, then we move to the drafting, right? So drafting means that communication, documentation, right? So 2D drawings or production drawings will be kept ready, right? Then we have the process. Then we have the process planning issues, right? Now, once we go for the process planning, we will have to find out if there is any manufacturing discrepancies in CAD database. Quite possible we have designed something and we have taken that fillet radius is, say for example, 5 millimeter. But while you go for the process planning, you will find that, okay, that kind of tool is not available. Or you have mentioned that surface finish of 10 micron is required. 10 micron is required, right? When then you find it out, okay, on your high speed machining is not available at the moment, or say for next 2 months it is not available, right? So that kind of things we have to check. Or maybe something you are designing or some process you have planned which is not possible without some other processes. So sequencing problem may be there, right? So that we have to check. If there is any manufacturing discrepancies are obtained, then we go back to the geometric model of conceptual design. And if not, then we can move ahead for the numerical control programming, right? For our CNC machining, right? Then finally we go with the machining, right? Then we can have the inspection of the part that whatever the NC programs we have developed, they are giving our the correct machining sequences and coordinates or not, right? Then we have the assembly of the product, right? Look into that in the whole process, what kind of softwares we need. And everybody should mention that what software at which stage we can add. So I will relate this with the previous talk, right? Look at this, the first stage. Geometric modeling and graphics package is required. Can anybody name few geometric modeling packages? For modeling and design conceptualization, and in the drafting documentation, if you can see here, in the middle portion we require another evaluation software. But for these two stages, right, we have the SolidWorks, we have CATIA, UG, or AutoCAD, which can help us in geometric modeling of conceptual design, and then we can have the design detailing and drafting documentation, etc., right? So this software, then you look for this portion, the design package we need to check. Can you see this red color and then yellowish color for design package? Is the design evaluation possible with available standard software? Yes, no, right? So if it is not possible, then we have to develop our own customized programs, right? So here we required like Abacus, COMSOL, ANSYS for design evaluation purpose, where we can apply certain loading conditions or temperature, etc., and we can see how your product will behave into that scenario, right? And if not available, then we need to have a programming package, right? So you may require to develop your own subroutines like from maybe in Java or MATLAB, right? So different programming packages are equally required for product development like this. Then we move ahead. We required computer-aided process planning packages, SAP kind of thing, where we can do all kind of scheduling. then feature extraction, feature identification. Okay, where is the hole? Where is the bore? Where is the fillet or chamfer? So from the geometric modeling, directly these kind of features can be identified and automatic geometrical programming can be done. Then we need NC programming and machining. So we require NC package kind of thing like Delcam, Power Mill, right? So which can feature identify and generate automatic tool path for our this, right? Then we go for inspection and robotics packages for assembly and inspection, right? So coordinate measuring machines, etc., non-contact type cameras, and then for making assembly, the robotics packages, etc., a requirement, right? So this is basically the utilization of CAD/CAM systems in a full industrial environment and in which areas, which software kind of thing is required, right? So these two things we talk, right? Then let me have your views on that before we move to the how we minimize the time and the time compression techniques for product development. Anybody would like to add anything to that? I think my slide sharing is stopped now, right?
Let me check, sir. Let me check. Who is interrupting, sir? Let me check.
So let me take few queries at this moment. Yeah, people are responding. Yeah, Satish Kumar, Rohi, Katia, Autodesk, Abacus, and says good. Okay, so I would like to that somebody may add some more product into that. Say, for example, okay, somebody is talking about concurrent engineering too. Okay, let me come back. Yeah, Dr. Naren, can you see my slide is visible now?
Yes, sir. Yes, sir. Yes, sir. It is visible, sir. Utilization of typical CAD.
Fine. Yes, yes. So let us move that from the product cycle and then how we utilize this product cycle in an industrial environment, what kind of software packages are required, the subroutines needs to be developed, right? Then we talk about, then we come to that time compression using additive manufacturing. As we are talking too much about industry 4. So how these things are going to help us in case of industry 4 and quick product cycle, short product cycle, right? But the large product life cycle, right? So the time compression, what we get from the additive manufacturing is that we start with the product design, right? So after product design, when it is over, just connect with my first slide, that after product design, we start the part drawing. Then we have the tool design. So product design, part drawing, tool design, and then we have the tool manufacturing, right? So go for assembly and test. And then finally the functional testing of the product will start, right? Once the testing is done, then we will move to the fixtures and the special tools, etc., right? Then we have the document brochure, right? So this is the our typical product cycle approach, right? These are the various operations we perform in a sequence. Start with the product design, part drawing, tool design, tool manufacturing, assembly and test, and then functional testing, right? and then fixtures and special tools, then document brochure, etc. Right? Then after that, if you look at that, if we introduce the additive manufacturing process, what is going to happen? Right? See, we still begin with the product design. But instead of going for the part drawing, what we have to talk about the AM parallel processing will start, then assembly, and then functional testing. Right? So this functional testing will go parallelly because we already have some prototypes, some tool and patterns, fully assembled model we have, so we can directly plan for the packaging things, designing of the packaging material, the boxes, etc. Right? And then parallelly on the main line after the model, we are designing tool design and then tool manufacturing for the mastering, maybe a high-end dies, etc. Right? So we are there. I will share some of the applications of metal additive manufacturing processes so you can understand how this tool manufacturing and tool design become very important. Okay. So let me share one figure. Okay. Right. So based on this, if we consider this here, the 100% time is required. So this after additive manufacturing, this time is reduces 10 to 50%. Right. So that is the time compression we apply in developing a new product. Right. And why this new development product cycle to be minimized? Then we will talk about the product life cycle. Right. So this needs to be kept as small as possible, because you see in the market, suppose you buy a tie today, right, for your son, and then you go after a week or after a month in the market, you will never find it again in the market. Because what happens, that the product life cycle was so small nowadays. So if you spend more time in product development stages, your competitors will launch their product quickly in the market. And quite possible when your product reaches to the market demand is already over. The product life cycle is even over before you launch your product. Right? So that's why nowadays we have to be very, very fast in acting to fabricating our product and launching into the market, patenting, etc. Our licenses issues to be handled very fast. Right? So here what is happening in this case as well, we have the time and cost saving by new way in modeling and manufacturing, and this also leads to a lot of paper saving, etc. At this stage, I would like to share one slide from some other product. Let me share one product, right? Yeah. Look at this product. Are you able to see my slide in this?
Yes, sir.
Yes, over some other presentation. Yeah. Look at this one product component. I am not switching over to metal 3D printing right now, but I am just trying to share one product. Why this product cycle to be minimized? Look at that, how this time compression becomes so important by applying the additive manufacturing. So when we talk about the tool manufacturing, we may feel that, okay, we are going to develop some small tool or lathe machine or milling machine. That is not the idea what I am sharing here. Look at these two products, right? And talk about, say, for example, this right corner product, lower right corner. Look at this for this assembly, right? How many components your die should have. So when after the solidification, when you do the casting of this product, right? So from your casting, how many component you should prepare that casting, right? Look at this. There is inner circle, right? So if you have a casting here, you have to break down from here, right? So you may plan for sand molding or something kind, etc. But look at this. if you try to make it by machining, how almost impossible is this? And if you try to fabricate it small components, then also it will be very difficult, because you require a lot of welding, joining, and then part strength will be compromised, right? So even I cannot rotate it, but you can see here. Okay, then now look at this component. How many components are there, and they all are intersecting with each others, right? So if you try to pour the metal in this to remove it from its casting, how much parts you have a casting, so that this part can be removed from its casting. Similarly, in this both the cases, right? So this is the advantage we gain when we talk about the product cycle. So look at this. Suppose you are going to launch a new washing machine in the market, right? And then also in that situation, with that washing machine, kind of say, suppose rotary motor is there, or some gear is there, some plate is there, how much time it requires. Okay, so that's the difficulty in product. Right? Look at this, some other components, when we have very small features are there, right? So here the time compression techniques like additive manufacturing needs to be utilized, right? That's the idea in that. Let me come back to right. So that's the advantage you see here, the product design, part drawing, tool design, we go with the tool manufacturing, assembly and testing, then functional testing, pictures, special tools, right? Look at this in the bottom figure, how we have reduced 10 to 50% just by bypassing it. After the product design, we have a product model, and you might have already gone through in various other lectures, additive manufacturing has no limitations on the features design. Whatever the complexity you can think, print it, right? So that may be the one product, but here, sir, what the product I have shown, that product may be required in a huge size, right? The number of items may be very high, right? So in that cases, here the side and then functional testing will start. And at the same time, you might be developing your dies, etc. Right? So dies design, tool manufacturing, etc. will continue to go ahead. Right? So that's the advantage we gain. Right? And that has become very important in view of that, what the very relevant title the organizers have selected, that Industry 4 and smart manufacturing. Right? So in case of smart manufacturing, what we have to consider in Industry 4, if I recall back, look at that, what we have in it. We will come back on this. What we have in Industry 4 we have, right? If we recall that the first mechanical weaving loom started in 1784, right? So that was the first industrial revolution by the mechanical production facilities with the help of water and steam power. So the generation was the important, the power generation was the important. Hydraulic power systems has come, then steam power, steam engines have started, right? Then in a first assembly line introduced in 1870s for automobiles, right? Where the product is running and then complete assembly line was there, right? So the industrial revolution came with the mass production with the help of electrical energy, right? Lot of conveyor systems, belt, robots, motors, etc. has come into the pictures, right? Then the third is started with the numerical control, right? Where the CNC machines have employed, the control was numerical. So mechanical, electrical, and now you can see the electronics has come into picture. So electronics and IT for further automation of the product. That was the Industry 3 as designated, right? very recent, you can say 1970s. Right now we are talking in today's environment that industrial revolution 4, right? That is on cyber physical production systems, means merging the real and virtual world, means you can control by sitting your office, your home. You can switch on off your AC from your office. You can switch on off your CNC machines. You can control your production rate. You can decide the product mix. You can see and execute your supply line or the assembly line, everything, right? So that is more dependent on sensors, chips, robotics, right? So where the decision, most of the decision making will be done by the machine itself. So a lot of cloud-based computing, machine learning, artificial intelligence, we apply into that, right? Right. So that is the industry 4. Now, if we are moving in towards the industry 4, what would happen to our product life cycle? That is the question taking back to us to the product life cycle, right? So what we have in the product life cycle, we manage its the development and introduction, the growth, the maturity, stability, and the decline, right? So if we talk about the 4 stages of the product life cycle, right? Introduction. What is that? The product has come into the market. Then its growth, means popularity, right? How the product has been accepted by the public and many people use this product. Then maturity, right? Top. Then decline, its demand goes down, right? So what the difference we have identified in the product cycle and product life cycle? Product cycle, all the design and manufacturing activity, the raw materials enters into your factory and the finished product comes out of the factory. And when we talk about the product life cycle, it's related to product. It's the product life, means when first it is introduced in the market and completely out of the market, right? At this moment, would anybody like to add any product where you find it out it is having very long product life cycle, right? And or it has have a very small product life cycle. Anybody? Before we take further discussion, let have some interaction. Yeah, somebody says Swapnil Devkar, mobile phone, apparels, garments, car. Okay, you are mentioning about the top. You see about how much reservation our parents have for a smartphone, right? They still want to have the key phone. But you see how many of us is still having the landline numbers? Suppose you buy a new flat, new house, new bungalow, right? Earlier, the first requirement was that to get the telephone connection for your home. No, I don't think many people prefer to have a landline number rather to have an extra smartphone if it is all it is required, right? So these are the way we are changing our requirements. Anybody else? If it comes to the telephone, smartphone, so you can see how we design our product and in an environment of industry 4 and how we see the product life. Anybody has heard about the pager?
Yes, sir.
Yeah, Abhishek Barua. When it was launched and how much time it was in the market?
So around 99, 2000, I think 1999, 2000 it was launched, sir. 98, 99.
Yes.
And it was a very because we used to see that we can only get message on that. We cannot talk, only get on message.
Yes. That is what I try to point out here. That you see, if we're talking about the product life cycle, you see how fast technologies had changed. And then you see that product didn't see any growth or any maturity, and its product life cycle has declined, right? and a good product has been launched only for text messages. Can we believe nowadays in a Facebook, WhatsApp, Twitter environment and using our smartphone for all such applications, right? And even we are prepared nowadays. We are having almost the video lectures daily, the video conferencing, etc. on our mobile phone. A product has been launched in the market just for text messages, right? And people were crazy about that product. People were waiting for that product. It has come into the market, and the new technologies has come, and then immediately that product has been out of the market. Right, that is a crucial example of the product life cycle. Right, so here we have to take care of various tools, how we are going to manage the product life cycle, how we have to give the continuous improvement in our product so that it can remain in the market. Look at this. Some new products are coming into the market, so you can have this kind of designs for physically challenged people, or maybe some accident or trauma cases where burning is there, right? So these kind of situations are there where you have to look for your products, right? And in case of product development stages, you can see this kind of scenarios where you can have very typical designs, assemblies, hinges, like the housing for drilling machine, guns, the car seat, a lot of experimentation, deliberations, decisions are required before finalizing such product, so that they can remain in a market for a long time. That continuous improvement is must, right? So look at that. Let us discuss few more points after this. Right, so I will not go, because this I feel that all are aware from the book itself, that what we do in the introduction, what we do in the growth and maturity and decline. So this is for any product. Only thing, how this axis can be long, right? For introduction, growth, maturity, and finally decline of the product, right? Right. So, like you see nowadays, what happens when we started with the smartphone? People were preferring 3.5 inch size and 4 inch, 4.5. Nowadays, around 6.3 inch phone we carry in our pocket. And what has been? This has almost reduced the requirement of the tablet. So what has happened? Smartphone size is started increasing, and your laptop size has started decreasing. So instead of 15.6 inch laptop, people are using 13.6 now. So that has give a good compromise, and then the product requirement of the tablet has been reduced drastically. Not many people are using tablet. Right? So we have to look for these situations, how long a product can be in the market. What are the available? What are the threats available? What are the competitors for your product? Right? Not maybe the similar product. Here, when we're talking about that, maybe a product only, maybe made by anybody else, but it is a product, right? So how it will gain maturity and decline will start, and how the new product will replace. Look into that. Let us have an open discussion on that. What kind of changes we require in this case? If we talk about how we are going to change our that strategy, right? So how the product life cycle will affect by industry 4, right? We talked about briefly what we are going with the industry 4, right? Lot of sensors technology would be there, cyber physical system would be there, very high-tech factories would be there. So what will happen? Finally, it will allow us to have the product cycle very small. Right? So what the effect we may have. Now I would like to have an open discussion with all of you. Another 5-10 minutes. I'm sorry, I have another meeting scheduled. I'm sitting in office, so I would be rushing in another 5-10 minutes. I would request all the participants to tell us how the product life cycle will affected by the industry 4. Say, first thing, the inventory management. how the inventory management would be affected by in the current scenario? Did you anytime notice how long car company guarantee you that they will provide the spare parts for you? How long Hyundai or Maruti Suzuki or any other automobile manufacturer will still continue to provide the spares after the car they remove from the market? Anyone?
Hello, sir.
Yes.
Actually, they are not guaranteeing that thing. They are only saying that we are giving you in warranty or something. They are not guaranteeing about the spare part and all. Because
that is the question. That when we start buy a product and company say, okay, this is 5-year warranty, it's okay. They will replace the part, but the product life here comes into picture. If we assume that my car have 15 years life, will I be able to get the spare parts for 15 years? Otherwise, what I would do for 15 years with my car? Right. So in case of that, company has to identify what is the product life, what they are selling into the market. So they have to accordingly maintain the inventory. They have to provide the spare parts for the car life. Suppose today you buy a car and you buy it for 15 years because as per the government norms, we have the RTO clearance for 15 years. Then again it can be extended for another 5 years. So we assume that company will continue to provide us. And if you are not sure, then company would be able to provide me the spare parts for another 15 years. You may certainly not like to purchase that car. So what will be happening with this industry 4 as the product development will be very fast, right? So with the product development fast, the product life cycle may be changing because you can launch quickly a new product, right? So that may be the scenario. Company may also think that they should design the product for repair or just use and throw. So accordingly, the cost of the product they have to maintain, right? They have to find out. Suppose you say now today we see VLSI, right? Many large size chips are there in our mobile. And earlier, if you go for a Paramount radio, and now you see on all such kind of small products, it's completely jam-packed in our smartphone, right? It would be very difficult to identify the circuit of a FM radio within a smartphone. I'm not an expert of that. Maybe it might be identifiable, but my thought is that the camera and other things, they are so amalgamated with each one of them, right? That company might be thinking that, okay, nobody would like to repair this product. They will use, and as soon as it is not in service, they will try to replace it. And in many of us, we can see how many of us are trying to repair our mobile phone nowadays. Right, so that may be the one scenario with industry 4, right? So accordingly, the companies may also think that products will be designed for a short span of life. Accordingly, they will maintain the inventory, or entirely they will think that certain products may be just for use and through purpose, right? Right? And then frequently design changes are possible with the industry 4, this revolution, a lot of sensors, machines, supply chains would be available. Right? Anything else anybody would like to add into that?
So the third point, products will be designed for short span of life.
Right.
So in industry 4, we are generally having a product which is customized in all respect, because when we talk about industry 4, we are talking about Internet of Things. So we are on cloud, so we can give our specification. So if I give my specification and that product is manufactured, I will keep it for longer period of time. So
yes, that is what I'm talking. If you yourself is involved in that, say for example, you design a bungalow for you, You don't even think about what would be the life cycle of this product.
Yes, sir. Yeah, yeah.
Plan it for your entire life, and even you think that your next 2 or 3 generation would live there. So if the product of this kind, customized, designed as per your specific needs, etc., right?
Yes.
Then you will think for the product longer product life, right?
Yeah, yeah, yeah. Yes, sir.
So I would end this session here and then open for some more queries at this moment. I would thank you all, right?
Yeah, thank you, sir.
Let me stop
Okay, sir.
presentation.
So now we can take some queries, sir. If you have please 5 minutes, then we can take some queries from our.
Let me stop presenting and let me available. Yeah. Yeah, if we have any queries on this product cycle and product life cycle, even if somebody would like to share his story or his thought process for these two things, product cycle and product life cycle, that would be good.
Sir, Mr. Satish Kumar is asking, what are the activities to be performed on PLM during economic recession to sustain in market? In the chat box, he is written his query, sir.
Many people are focusing on service, I would say. That is the point, because this is a complete cycle. People should have money, they will have the buying capability, they will buy the product. Once they buy the product, then more production is required. Once the more production is required, the more salaries, more people will employ it. Then again, when more people are employed, then more people will have the buying capability. So that is how this recession is work. This is more on psychologically. If you see that, okay, recession is coming up, you start collecting material. If you stop spending money, what will happen? Your money will be in the bank, right? And then very less interest you will get. But because you do not buy anything, industry will day by day going down. So that the whole economy will go down, and then recession will continue. So that is the point where the government looks. Many as an individual we can't help in such kind of recession things, but the products will be like, you see many many products I have seen in this COVID situation, requirement hearing, this situation will come. People are designing masks, right? Now the requirement will come how to dispose these masks. In the last 2-3 months, I have around 50 masks at my home. I don't know what to do with them. I have used it, tear off or something has happened. I cannot use them, right? Now I'm thinking, just like you see, can you remember when the polythene was invented and the first carry bag might have come to the market? What revolution? Okay, now how to dispose of it, right? So these are the look at that we have to work in innovative environments. Even in the recession case, people are still living, still surviving. Only maybe requirements are changing. So companies should be adaptable for such changes in the market. And look for all such changes from one product to another product very quickly. They can the industry Akash Jain COVID due to inequality, you can see here. Right? So that is the industry 4 that is talking about you should apply all your smart manufacturing technology for manufacturing purposes. That is industry 4. When we are your smartphone to say location. Immediately, if you talk, anybody send me the address. You look at the WhatsApp. Nobody is typing your address. You just share your location. Why can't you put this kind of on your product so you can load it quickly at this particular assembly or product line where it is lying? So that's all only. ST4 is nothing applied for industry as well.
Sir, I think, sir, there is network connection issue from your side because your voice is not clear to all.
From my side?
Yes, sir. Yes, sir.
Okay.
Network connection issue, I think.
Now voice is clear?
Yes, sir. Because yeah, it's now it's louder, sir. Yes, clear.
Okay, Dr. Naren, if no more queries, we can close the session.
Okay, sir. Okay, fine. Okay, so thank you, sir, for explaining well this topic to the participants, and I hope now the product development life cycle management topic is clear to our participants. So I am really thankful to sir for sparing your valuable time with us and to speaking about the topic with our participants. Thank you, sir. Hello.
Thank you, Dr.
Thank you, sir.
Dr. Aviral. Good day.
Thank you, sir. Thank you very much.
Thanks to all participants. Okay.
Thank you, sir.
Okay, so dear participants, so today we are stopping at this point, and tomorrow we will again meet at 10 a.m. So thank you very much. Thank you all for attending the today's session. Thank you.
Thank you, sir.
Thank you, sir. Thank you very much.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you, sir.